Good afternoon, everybody. Now I think it's time to start. I saw several participants already joining, so I can see also our chair and the rapporteurs are also there. It's nice to see some known faces and known names. We have several colleagues also helping us with the logistics, so please, colleagues, I let you support us with some issues that I can see here in the chat. Let me just start and welcome you all to the 26th EFSA Scientific Colloquium. First of all, I'm happy to see so many participants, and I'm sure that in the next 2 days, we are going to ensure a good debate and a lot of scientific discussion. There is an echo. Maybe, please, could you check that your micros are off? Okay, hope it's okay now. First of all, well, let's hope that it is working now. Let me introduce myself because some of you, you don't know me. I'm Claudia Roncancio. I'm the head of, recently I started this position. I'm the head of the methodology and the scientific support unit. So this unit is also dealing with the scientific committee. And as I was before in other units dealing with other issues in EFSA, initially I started with feed additives, and I was there as head of unit for almost 10 years. And since 2015, I moved and I was working on the food ingredients and packaging. Now I have the opportunity to lead this horizontal unit, providing cross-cutting support to all units and panels in EFSA, as well as some further forward thinking and supporting EFSA in the strategic planning for the future. I'm happy to be here today, welcoming you, introducing the 26th colloquium. I went back to a little bit to the history of the scientific colloquium, and we started in 2004. And EFSA aimed to engage in a scientific discussion and a debate with a number of lead scientists. This opportunity, we have 168 participants coming from many different affiliations. We have participants coming from academia, from the food industry, international organizations, research institutes, and they have a very wide scientific background. Exposure assessors, nutritionists, risk assessment experts, risk-benefit analysis experts, and we count also with the participation of risk managers. But what are we going to do? Because once we do this type of events, we need to have a follow-up. And the follow-up for us is extremely important because with the outcome of this debate, EFSA provides, this helps EFSA on forward thinking on future strategies or long-term planning, but also the outcome of these meetings support us in the preparation of, for example, a guidance document or an opinion. And this is the case of the scientific debate that we are going to take, that is going to take place in the next 2 days. Today, we are going to have 6 invited experts that are going to opening the scene or opening the event. Then we are going to have 3 breakout sessions, one on the needs, on the methods, and on the data. And on Thursday, we will all reconvene on a plenary session to get the final outcome of the breakout sessions and as well to have the take-home messages. Take-home messages, extremely important from us. We have several colleagues from EFSA acting as rapporteurs. The overall rapporteurs today are Maria Bastaki and Luisa Ramos. As well, there is a number of colleagues from EFSA, experts that have been working and preparing the agenda and preparing the discussion for this event. And I would like to thank you to all of them. Now we are several technical support colleagues. Please, we are also in your hands that you are going to help us in making the technology functioning the best for all of us in the breakout sessions and then in reconvening in the plenary sessions. With these words, I would like to give the floor to the chair, Dr. Margaret Jones. He's also very known for, I would say, probably most of you. Mr. Chair, I think I would like to give you the floor to start with your presentation. Thank you very much.
Thank you very much, Claudia. Thanks a lot. Actually, for those who don't know, Claudia and I have been teaming up since at least 2015 in various functions. So it's a pleasure to see you in this new function and to work with you at the very start of your new endeavor, I would say, within EFSA. Let me also start by introducing myself very briefly for those who don't know me. And I think there are a few, Claudia, who don't know me at all. So I'm Maged Yunus. I'm a retired professor of toxicology and biochemical pharmacology, and I'm a former director of food safety and zoonotic diseases at the World Health Organization. It's actually history because I haven't had that position since 2013, so it's quite some time now. But I've never left the field behind me and have been working with EFSA ever since as an expert, and with really great appreciation and pleasure. So let me now give you a little bit of an introduction to what we're planning to do today, and a little bit of history to why we are meeting and why we're addressing this issue. And I don't know, Maria Bastaki, if you're ready to share my presentation for me. Maria, are you there?
Yes. Maged, just give me 1 second.
Yeah. Don't worry. We can. We have time. In fact, to talk a little bit about the background until you see it. There's always a scientific and also a managerial need behind the work that we are doing. And of course, the scientific side is to understand better what is the scientific basis and what are the new developments for assessing risks and benefits, and for weighing risks against benefits. That is one. And of course, there are the management needs, and there are also the consumer needs that we need to address. So with that, let's take the next slide, please, Maria. Thanks a lot. So in this presentation, what I'm going to do is give you a little bit of a background. And the background is really that there is a request from for scientific advice from the European Commission. And we will get into the details of that at the beginning. And I think I don't know if it's only me who sees this double.
Yeah. Maria, we are seeing both screens. I don't know. Yeah, me too.
Okay, let me try again. Unfortunately, I'm out of.
Yeah,
end the slideshow.
Yeah. So.
Okay, let's try this again.
Yeah. So, colleagues, it's in fact, my mistake that I didn't feel comfortable sharing from my computer being in the southern part of Europe at present, and I'm not really an excellent technician, if you like. So that's why I asked Maria to help me with that. But anyway, here we are. So I will talk a little bit about the request for scientific advice from the European Commission, and then about the next step, which was how to translate this request for scientific advice into a work plan for EFSA as to address the questions posed, because it needed a little bit of forward planning and of identifying steps and milestones along the way, which resulted in the development of a multi-annual program between 21 and 25 to really come to answering the question raised by the risk managers at the Commission and EU member states. And one step of those is the updating of the EFSA's risk-benefit assessment. We'll talk about that in more detail, and then I will get into the overall objectives of this scientific colloquium. So if I can have the next slide, please. Why do we do a risk-benefit assessment? In fact, there are various reasons. First of all, consumers would like to see the full picture. So they don't want just to know about the risk from the presence of certain chemicals in food or from microbiological contaminants alone. They would like also, and they don't want to hear only about the nutritional benefits. They want to see the full picture. How can we balance the potential risks versus the nutritional benefits, and what is the overall picture? It's not really just balancing, it's really understanding what is the end result of knowing about risks and about benefits in terms of consuming food. The risk managers need, of course, to obtain all the necessary information, because any action they take needs to be scientifically informed, it needs to be balanced, and their decisions need really to be helpful for the consumers, and of course, supporting their health. So what the risk-benefit analysis should be able to do is to enable the weighing of the evidence on risk and benefits in a meaningful manner, in a way that is really not only scientifically sound, but also results in an outcome that is understood and translatable into action. So the next slide, please. We'll go back to the background for this work that we started. The European Commission, DG Santé, asked EFSA in August 2020 to provide a risk-benefit assessment of fish consumption in relation to the presence of dioxins, polychlorinated dibenzodioxins and dibenzofurans, as well as dioxin-like PCBs, taking into account the estimated exposure of these contaminants in relation to the established tolerable weekly intake that was established by EFSA of 2 picogram per TEQ per kilogram body weight per week. In addition, the Commission asked that EFSA assesses the influence of the presence of other contaminants in fish, such as methyl mercury, brominated flame retardants, and perfluoroalkyl substances, and to what extent the presence of these contaminants would influence the risk-benefit assessment to be provided. So it's a very complex question, if you like. And then in the next one, we will have a look at, what are we encountering in fish. So in fish is a very nutritious and valuable food, particularly since it provides the body with long-chain polyunsaturated fatty acids that are, of course, as we all know, very important for our health. Vitamins, particularly, of course, lipophilic vitamins, vitamin D in particular, and of course, a number of minerals, calcium, iron, selenium, zinc, to name a few. But of course, we know that fish, depending, of course, on where it is caught, how it is, its body composition is, and so on, may actually be prone to contamination. We mentioned already the persistent organics like dioxins, brominated flame retardants, PFAS, perfluoroalkyl substances, but of course a number of organometallic contaminants, particularly methyl mercury. So here we are faced really with a large amount of contaminants versus a really high level of nutritive value. So what we're seeing is actually a group of substances with different health effects that are completely different, and that have, of course, a number of different health-based guidance values, dioxins, methyl mercury, and so on, and of course dietary reference values for different endpoints, We have also differences in the levels in various types of fish. And of course, we know that fish is not always and not everywhere in the world the major source of dietary exposure. So here again, we're faced with a variety of potential exposures that we need to deal with. Next slide, please. Okay. So following the receipt of the mandate, there was, of course, an exchange of views with the EU risk managers, both at the Commission level and with member states. And the feedback was that what they needed was really a scientific advice that would support them in defining dietary advice on consumption of fish. It's not really about looking, okay, here's the risk, here are the potential benefits, and over to you. I would really like to see a kind of an approach that is modern and that really gives them the feel for how they can base, on which they can base their decisions. And in that discussion, several member states considered that an approach to estimate, for example, what is the percentage of the health-based guidance values for dioxins would come through the consumption of certain types of fish, and what is the percentage of dietary reference values for various nutrients is reached through that consumption. They considered this is really a fragmented approach and not sufficient. What they wanted is scientifically based advice on how to weigh the risks and benefits of the combined exposures, both to contaminants and nutrients, using a matrix that would allow them to take a decision. And in this context, EFSA noted that there is a need to update the existing RBA guidance risk benefit analysis guidance that was already prepared by EFSA in 2010 to help risk managers to define their dietary advice at the national level. So the next slide. Here is a little reminder on the existing guidance in human health risk benefit assessment for foods of 2010. And of course, you cannot read this slide, so we'll take the boxes one by one. The next slide will show you the first step, which is following the problem formulation when we define, okay, what is the question that we want to address in the risk benefit assessment? We define the the terms of reference for this risk benefit assessment, and an initial assessment is conducted comparing, what we have on the two sides. So if we can see, following the initial assessment, that the risks by far, outweigh the benefits, then the question is relatively easy to answer. We have to go back to the risk benefit managers, and propose that we can stop the assessment at this stage. Same thing, if the risks are far lower than the benefits, then of course the benefits are clear, and we can report back and propose to stop the further evaluation. But if the risks and benefits do not clearly outweigh each other, then there is a need for further refinements. So we need to refine the assessment with additional data, and it maybe identify additional data that are needed to be able to go ahead. So the next slide will show you what we do then. So in refining the assessment, we could ask for a refinement of exposure data, comparison of different scenarios, looking for additional information, refinement of the hazard or positive health effect assessment. Can we do a better dose response modeling on both sides? Can we do a consideration of different population groups or different populations, different parts of Europe? If we do, and the risks still overweigh the benefits, then of course we report back to the risk management managers, and the same if the risks are much lower than the benefits. But if we can still do not see that one overweighs the other, then we have to consider another step, which is, can we convert the two sides into a composite metric, something that allows us to compare them really in a kind of direct approach. If the conversion into composite metrics is not possible, then again, it's back to the risk management managers to either end the assessment or to identify additional data needed. And if it is possible and data are available, then we can report back, that's on the right side, to the risk management managers and propose to refine the assessment using that composite metric. If, by contrast, the conversion into composite metric is possible, but we don't have the data, then we can identify the data needs and go back to the risk management manager to ask for the ask them to make these data available or request them. Then the final step in the next slide would be that if we use the composite metric and we can compare the risks and benefits because we have the data, then the outcome will be reported back to the risk benefit manager. The current assessment can be completed. Maybe one could also identify additional data needs to further refine the assessment, and that would be communicated as well as some kind of conclusion or recommendation or identification of additional information that can be provided. So this is the stand of the 2010 guidance, with a possible outcome being, if we look at the fish consumption, when would the fish consumption exceed a certain health-based guidance values of a certain substance? So again, one substance at a time. Or how much fish should be consumed to meet the dietary reference value for a certain nutrient? Again, nutrient by nutrient. And then one would compare the risks and benefit using a composite metric, which is currently mainly the DALYs, the daily adjusted, disease adjusted life years, or the QALYs, the quality adjusted life years. And these are, if I allow me to be a little bit inexact here, they're actually based on economic considerations mainly. That's in the background of them. So what the guides will not provide is really a comprehensive assessment where you put all the risks and all the benefits into an overall context. And you cannot actually currently translate fish consumption, if you eat so and so much, into an overall health outcome. What is the overall health outcome, weighing the risks against the benefits? What is the final outcome? And then you cannot also do a characterization of risks and benefit by individual fish species, by types of fish, wild versus farmed, or by population groups, those who may eat more fish than others, those who are more vulnerable. So it does not allow you to do targeted dietary advice or consumption warnings. So in the next slide, you will see that bearing this in mind, there was a feeling that the RBA guidance needs to be updated as a prerequisite for completing the request by the European Commission to do the risk-benefit analysis of fish consumption versus PCDDs, PCDFs, and other contaminants. So the plan was to create a working group for the scientific committee. This was done in November of last year. For the scientific committee to agree on the terms of reference for this working group, which was done as well when the group was established. And then as a first step, to have this scientific colloquium, particularly to really collect your ideas, your views, what kind of information you can offer, what kind of models are there, what is the state of the science today? How far did we go beyond the DALYs and QALYs? Is there any way that we can provide this composite approach to giving a dietary advice? And this is taking place right now. It was the first function of the working group, was being assisted by a large number actually of colleagues from the EFSA, among EFSA staff, to really prepare for this Colloquium, and we're looking forward very much to hearing your views and having your feedback that will facilitate the further work of this working group and of the scientific committee. And then based on the outcome of this scientific colloquium, the work will start immediately thereafter to update the guidance, and it will be put out for public consultation, hopefully next April, followed by an international workshop to discuss the draft guidance in light of the feedback we get from the public consultation. And then the plan is to finalize the guidance and seek the adoption of the final guidance by the scientific committee in September, so that it is published in November of 23 and is ready to be applied for the specific task of weighing the evidence of fish consumption versus the contaminants present. So the next slide describes what the working group will do in particular. So the first thing, which we've just talked about already, is to contribute to the design of the agenda of the scientific colloquium and to extract the outcome of it and use it for the update of the guidance. Utilize this input from your side to draft the updated guidance on the risk-benefit analysis. The working group includes expertise in toxicology, epidemiology, nutrition, risk-benefit analysis, social science, and communications. And this is very important. We know that how important risk perception, risk communication are, and therefore, really, it's a big step forward, really, to take on board social science input. And of course, the working group will be seeking additional input from other experts in various fields. And then the working group will also build on the expertise present in EFSA scientific units and panels, including the communications unit and the engagement and cooperation unit. So a very broad scope, but in fact, very much focused on coming up with a useful guidance. So the next slide, again, the terms of reference were to update the guidance on human health risk-benefit assessment of foods that would result, and again, let me stress this point, in outputs that would serve the needs of member states that issue advice for food consumption at national level. We really want to go a step further than what was out there so far, and also to update additional aspects of the guidance as needed, in line and consistent with the current state of the art in risk and benefit assessments, and of course in light of the experience that EFSA has gathered with its output since the time of the issue of the last guidance. Next slide, please. The scientific colloquium, therefore, aims at, in the very first place, at collecting your views on the current needs. So that's why we have risk managers who will help us to identify the needs of risk managers, and also, of course, possible approaches to go for this kind of comprehensive risk-benefit assessment. And therefore, we have, representatives of various areas of science and also, of course, of various parts of the society to serve as input for the scientific committee to be considered during the update of the guidance value. Specifically, we would like to receive your input on advances in risk-benefit assessment methodology, the needs, and the experience from its application. So here's really what we're really asking you to contribute during this colloquium over the next 2 days. And then, as you know, it's taking place online. We're starting, as Claudia said, with presentations by internationally renowned keynote speakers. And all of the colloquium will be streamlined. Before I went online here, I saw that there was already an announcement on YouTube and other channels. So it'll be available to be watched outside as well. So next slide, please. The program is just in a bit more detail. As you see, the opening session, what we want to achieve here is to understand the needs of risk managers. That will be through the presentations, to hear more about current approaches to risk-benefit analysis, about the risk-benefit assessment of breastfeeding, nutritional health benefits of food consumption, and of course on the influence of trust and perception of risks and benefits of food consumption. So it's really just to frame the questions. That'll be our first day. And then we'll have breakout sessions to look at the needs. How can we get a risk-benefit analysis that would better support developing dietary advice? The methods, how can we weigh health risks and health benefits in a combined dietary exposure in a comprehensive approach? And then the last breakout session will deal with data. So what data are there? How can we collect better data? And what other information do we need to be able to conduct a meaningful risk-benefit analysis? And then in the concluding session, in the last morning, we will look at possible direction to take for the EFSA Scientific Committee working group in updating the guidance, but also, as you know, there will be an event report that will come shortly after the end of this colloquium. So the next slide is actually the last one. So thank you very much for your attention. And I think we are a little bit ahead of time, but we can still, I think, move on to the next presentation. So let me then start by introducing the next speaker. Thank you very much, Maria, for sharing for me. You made my life much easier. So I would like to introduce my friend and colleague, Frans Verstraete from the European Commission. Frans is a very well-known risk manager, but he's also a scientist and with experience in risk assessment. He's an agricultural engineer who graduated from the University of Ghent in 1985 and worked after that both at the University of Ghent, but then at the Belgian Ministry of Agriculture, being also a technical advisor to the Belgian Minister of Agriculture for a period of time. And he's been working since 2000 for the Directorate of General Health and Food Safety at the European Commission, having worked since 1997 in other places in the Commission. And it's my pleasure that I have actually had the chance to interact with Frans in various positions in the Commission. He is currently responsible for the elaboration of development and management of the EU legislation on certain contaminants in feed and food. So Frans, with that, hand over to you. The floor is yours.
Thank you, Margaret, for the nice introduction. And I will share my presentation. I already warned the participants that indeed the presentation is not so colorful as the one of Margaret, and is also, I would say, to a certain extent, there are issues unavoidably which will be coming back repetitive. But okay, I hope that with the presentation I will be able to contribute to have a better understanding of the background, why, and particularly also for contaminants, we need indeed scientific advice on risk-benefit and assessment in support of indeed dietary advice. So, first of all, a bit of background. Of course, you're all aware of the European Union General Food Law, the Regulation 178/2002, and also even already, let us say, 9 years before the General Food Law, we had also already the Framework Regulation on Contaminants in Food. And in fact, both regulations indeed had a basic principle that the food legislation shall ensure a high level of protection of human life and health. For instance, and that the contaminants legislation that was particularly translated, of course, first of all, is to say that indeed this food legislation shall ensure, and that has to be indeed translated into the fact that the food placed on the EU market has to be safe. And in the contaminants legislation, this was translated more detailed, saying that a food containing a contaminant in an amount which is unacceptable from the public health point of view shall not be placed on the market. So this was already back in 1993 provisions. When we are talking about contaminants, in fact, there we talk about a substance which is not intentionally added to food. So it's something you cannot always fully manage, but this is present in food as a result of the production, also of indeed the manufacturing, of the processing, preparation, treatment, packing, packaging, transport, or holding of food, but also as a result of environmental contamination. Another basic principle in EU legislation is that contaminant levels shall be kept as low as can reasonably be achieved by following good practices at all stages of the production chain, from the farm to the fork. And this principle is known by its acronym, the ALARA principle. So, of course, the framework legislation says also, when it is necessary for protecting public health, maximum levels shall be established for specific contaminants. And the regulation 315/93 sets out a procedure for setting maximum levels and includes also what is important for enforcing the legislation, a reference to the sampling procedures to be applied and the method of analysis to be used. It also indeed contains the requirement that we have to consult EFSA, in particular, and more in particular, the panel on contaminants in the food chain, the CONTAM panel, and before we can adopt provisions having effect upon public health. Before we can set maximum levels, we need to have an opinion from the CONTAM panel. When we then indeed, the establishment of maximum levels is taken into account, of course, the outcome of the risk assessment performed by EFSA. But also, and this is an important aspect, that we are also looking at the fact not only at the outcome of the risk assessment, but also what levels can be achieved by following good practices at all stages of the production chain. And of course, we have also to take into account other legitimate factors, as there are, for instance, availability of methods of analysis to which levels can a method reliably measure the levels, because we cannot set a maximum level which cannot be reliably analyzed. And this, indeed, all in the frame of ensuring a high level of public health protection. And in most cases, or in several cases, compliance with the maximum levels ensures that the European citizen is exposed to a contaminant at a level below the health-based guidance value, which is the outcome of the EFSA opinion, or results in a margin of exposure that is of no health concern, or is because of the lower health concern, no priority for risk management. And of course, but what we can see is that the presence of not all contaminants in all foods can be minimized or prevented by applying good practices to levels that ensure a human exposure below the health-based guidance value, or result in a margin of exposure that is of no health concern for all population groups in all exposure scenarios. Because the presence of a contaminant in food is related, or sometimes, or in many cases, related to factors that cannot be fully managed by the actors in the food chain, be it the fisherman, the farmers, or the food business operators because of, for instance, unavoidable historical background environmental contamination. Not speaking about hotspots of contamination, but really the general background environmental contamination. Also, we know, and when we are talking about processing contaminants, which are formed during processing, the processing steps are needed to obtain the food you wish. Also, we know that climate change and extreme weather conditions can make, for instance, mycotoxins more present in our cereal products. And of course, the individual farmer cannot indeed manage, control the climate or the weather conditions. Also, we see, for instance, more recently that with indeed the climate change, we see a more problem with indeed the contamination of crops with weeds which contain alkaloids, like pyridine alkaloids, or indeed also propane alkaloids, which are previously not so present in the in our crops. Furthermore, indeed, also farmer and food business operators, they are also confronted with, I would say, conflicting objectives, because one of the issues which is saying that indeed with the Green Deal, where indeed the policy objectives are more than legitimate, but for instance, indeed, if you have indeed non-cultivated borders of the fields, they are indeed a source of weeds or presence of indeed plants with indeed high levels of certain alkaloids and can infest the fields, or indeed, although it's not the only mitigation measure, and the reduction of the use of pesticides might result in higher levels of mycotoxins due to indeed more fungi, or indeed due to the presence of plant toxins due to the presence of more weeds in a field. So there are indeed these conflicting objectives, which indeed also the actors in the food chain has to manage. So, but we have also to acknowledge that such foods, where the presence of a contaminant cannot be prevented or minimized to a sufficiently low level by applying good practices, can be a very important source of nutrients, of which the intake is necessary for public health, and consumption of these foods may provide indisputable nutritional benefits important for public health. So it is important that such foods remain available for the consumer because of these nutritional benefits. And it's therefore necessary that the nutritional benefits of these foods are weighed against the potential risks related to the presence of contaminants in these foods. Now, coming to the example, and also what Maggot was referring to, is indeed the trigger of this request, of this mandate to EFSA, was in fact the EFSA opinion in November 2018 on the risk for animal and human health related to the presence of dioxins and dioxin-like PCBs in feed and food. I tried to summarize, I think, a 350-page scientific opinion in the 3 bullet points, which indeed, whereby the EFSA panel on contaminants established a tolerable weekly intake of 2 picogram toxic equivalents per kilogram body weight a week, and also came to the conclusion that, taking into account the occurrence of dioxins and dioxin-like PCBs in our food and the consumption data from European countries, the estimated human exposure to dioxins and dioxin-like PCBs exceeded considerably the tolerable weekly intake for all age groups. And fatty fish was identified to be a main source of exposure to dioxins and dioxin-like PCBs. Referring then to the EFSA opinion in 2005 on the risks and the benefits of the consumption of wild versus farmed fish, we see, of course, not only in that opinion, also in a lot of other scientific literature, we can see that fish is an important source of proteins of high biological value, of long-chain polyunsaturated fatty acids, certain vitamins and minerals, as also Maggot has already pointed out in his presentation. And so there is indeed the evidence that fish consumption, especially the fatty fish, benefits the cardiovascular system and may also benefit fertile development. So, but when we are looking at the issue of risks, benefits, we can also see that indeed within a population, different population groups have a different susceptibility towards the adverse health effects, risks, or risks related to the presence of dioxins and dioxin-like PCBs in fish. We talk about the vulnerable groups of the population. On the other hand, we know also that the nutritional benefits of the consumption of fish might be more beneficial for certain population groups than for other populations. They are beneficial for all people, but they might be more beneficial for certain population groups than for other ones. And so, in fact, it's not only about weighing the nutritional benefits versus the potential risks, but this has also to be done for all different population groups, because the risks can be different for population groups and than indeed the nutrients, the nutritional benefits. And so, in fact, in dietary advice that then indeed the risk managers gives to the consumers, consumption advice should provide for the different population groups what I call it, the optimal balance of maximizing the nutritional benefits and minimizing the potential risks. So, what is now the importance of dietary advice? And we know that the consumption of certain foods is important for public health because they are an important source of nutrients. We know also that maximum levels established on the basis of the ALARA principle, as low as reasonable achievable by applying good practices, thereby ensuring the availability or the supply of the food to the citizen, might not, in all cases, for all population groups, ensure a sufficient high level of human health potential. Therefore, dietary consumption advice towards all population groups and or targeted towards certain vulnerable groups of the population is extremely important to supplement the regulatory levels to ensure a high level of human health protection. And so this is indeed the need for scientific advice related to dioxins and PCB. So we need this scientific advice to provide us an updated risk-benefit assessment of fish consumption in relation to the presence of dioxins and dioxin-like PCBs. And this in support of defining a fish consumption advice at national level for different population groups to ensure that this advice provides an optimal balance between maximizing the benefits and minimizing the risks, but also taking into account national consumption patterns, differences between fish species, and also availability of certain fish species on the domestic market. Important also is within this request for scientific advice, that going back to the opinion from EFSA in 2018, they recommended that the toxic equivalent factors should be re-evaluated in order to take into account new in vivo and in vitro data. And upon also a request from the European Commission, the World Health Organization is currently undertaking this review of the TEF values and with the active support from EFSA, for which my thanks. And this updated risk-benefit assessment of fish consumption related to the presence of dioxins and dioxin-like PCBs has to take into account these. Of course, I cannot anticipate the outcome of this review, the possibly updated TEF values, as this might significantly influence the estimated exposure. For those who are a bit familiar with dioxins and dioxin-like PCBs know that PCB 126 is mainly now within all dioxins and dioxin-like PCBs, a significant contributor, and particularly also for fish, within fish. And it is exactly for that value that EFSA has some indications that this value might be needed to be updated. So this is, of course, important to take that into account. And according to the timeline that also Maggot has put forward, this review of these TEF values will come in time to be able to take that into account in this updated risk-benefit analysis or assessment. But also Maggot has already also hinted at, it's not only about dioxins and PCBs in fish. It is indeed, we know that the consumption of fish is also a major important contributor to the human exposure of methyl mercury, brominated flame retardants, and perfluoroalkyl substances. And we know, indeed, EFSA has issued opinions on methyl mercury and also more recently on perfluoroalkyl substances, in which indeed they also indicate a potential concern for public health. For brominated flame retardants, opinions were issued back in 2008, 2009, but currently EFSA is indeed working on updating these opinions, taking into account the many toxicity studies available and also occurrence data that has become available since then, has already finalized the opinion on the hexabromocyclododecane, is currently finalizing or working on the polybrominated diphenyl ethers, and still with bromobisphenol A and the other brominated flame retardants are still to come. But indeed, these opinions will become also available in the coming years. And of course, the influence of the presence of these contaminants on the outcome of the risk-benefit assessment has to be assessed, because indeed the dietary fish consumption advice, I come back again on my sentence, needs to provide the optimal balance between maximizing the beneficial effects whilst minimizing the risk related to the presence of all contaminants, because it does not make sense that we have the consumption dietary advice on fish consumption related to the presence of dioxins, and that we have then a contradicting fish consumption advice that we have to eat more other fishes because of the presence of perfluoroalkyl substances, or indeed another advice as regards fish consumption related to the presence of methyl mercury. It's important that all these issues can be integrated into one comprehensive, indeed, dietary advice towards the consumers. And this, of course, means that the presence of all these different contaminants has to be taken into account into the risk, has to be included into the risk-benefit analysis. So, as already Maggot said, it's not it's not a simple exercise. It's a complex, certainly not a straightforward issue, even if I'm not a scientist. And there are different contaminants results in different adverse health effects, affecting, in a more or lesser extent, different groups of the population. The presence of the contaminants is different in different fish species. I take here just some minor, some general differences, but there are also more fine-tuned differences between even fish species. Certain fish species contain much higher contaminant levels than other fish species, but for instance, we know indeed that dioxins is mainly indeed concentrating in the fatty fish versus the lean fish. That is indeed because dioxins are hydrophilic, are lipophilic contaminants, while indeed hydrophilic contaminants might more concentrate, for instance, in predator fishes like swordfish, where you have then also higher levels of methyl mercury. The contaminants can have different adverse health effects towards different populations, but also the nutritional benefits, as I already said, might be different for population groups. And the presence of the nutrients might also be different in different fish species. Again, here you know, for instance, the PFAS are more predominantly more present in fatty fish versus lean fish. So this is a major challenge for the scientific advice, for the comprehensive scientific advice risk-benefit assessment that the Commission is asking to EFSA. And for that we have indeed full understanding of the time that is needed to come to a conclusion of this. But in fact, looking a bit ahead, it's not only about dioxins and PCBs, not only about only fish. We have also this risk-benefit assessment will be possibly needed also for other contaminant food combinations. And I think I'm there particularly thinking, without going into detail, on the combination of, for instance, mycotoxins, combination with breakfast cereals and cereal flour. We know that mycotoxins are more at higher levels present in the bran of the cereals and in the outer layers of the cereal grains. On the other hand, we know also that the outer layer of the cereal grains, the bran, are an important source of fiber. And so we all know the nutritional beneficial effects of high fiber breakfast cereal, of wholemeal bread, of whole bread with whole grains. But on the other hand, we know that indeed these contain higher levels of mycotoxins, because also the mycotoxins are more concentrated in the outer layers of the grains. So here we have also already this issue of indeed setting possibly the need to set higher levels, because they are lower levels are not achievable in these high fiber breakfast cereals than in lower fiber breakfast cereals. Are they more healthy? Well, that is indeed where it comes, because on the one hand, these high fiber breakfast cereals are more, for sure, more nutritional, provides more nutritional benefits, but contain higher levels of microbes. We have that also the case with acrylamide, where indeed asparagine is mostly also concentrated in the outer layers of the grain, so it's not present, of course, in the starch of the grain, and so also there we can see that also in high fiber breakfast cereals and whole meal breads, we see higher levels that in of acrylamide than in the low bran breakfast cereals or in white flour breads. And so in the future, we indeed, scientific advice will also have to provide the basis for risk-benefit assessment also for these combinations of contaminants and foods. And with that, I thank you for your attention.
Thank you very much, Franz, for this comprehensive presentation. It's been, I think, very enlightening, I would say, and went into quite a bit of detail of providing information. So thank you very much. This is very much appreciated. So, colleagues, I think we can open up for discussion, but before we do, let me just give you a little bit about the rules of the game. So we will not be giving the floor to anybody. It's actually anybody who has a question, please enter it into the chat, put it as a chat message, and post it to everyone. And then as we go along, we might need to prioritize questions in order to make sure that we address the most relevant ones before the others, but all questions will be addressed in the end. And these are the questions that we will ask after each presentation, just for clarification, for better understanding. The general discussion should follow after the breakout sessions, where we'll have always enough time to discuss the various questions. But now, colleagues, if there is anybody who has a question he'd like to ask or she'd like to ask, please put it in the chat and post it to everyone. I don't see any, so Franz, maybe I can start by asking you, what about when we talk about, the risk-benefit analysis related to, I mean, it has nothing to do with our meeting today, but just really to understand, when it comes to microbiological contaminants, I mean, you mentioned mycotoxins as a product of microbiological contaminants, but to what extent do they play a role? Because, I mean, they are acute, not chronic toxicants, but to what extent would they play a role in any managerial decision?
Well, when I'm talking here, because of course I'm also of more in the chemical risk management. But for instance, we know that, for instance, if you are frying at lower temperatures, you have less acrylamide. But of course, the product might be less dry and might then be more indeed vulnerable for microbiological contamination. And so there, indeed, this has also been said, and when we indeed would set strict levels for acrylamide, then people might tend to indeed fry or cook at higher temperatures, which might then increase the risks for microbial contamination. So there is also already within the risk management these different risks that we have to manage, because indeed certain I would say mitigation measures for microbial contamination do increase the risk for chemical contamination. So we have also there to find within the risk management the correct balance. Yes.
Okay, thank you, Franz. Let me give a chance to anyone who would like to ask a question. Okay. Now, there is one question about the looking at how the an HBGV would apply to various subgroups of the population. You mentioned that. So is it beyond, that's my understanding of the question, the initial approach that, you would look at the most vulnerable group and then you would be automatically protecting everyone, or does it go beyond?
Well, if I have to answer this, of course, I'm looking at EFSA, because we as a risk manager, as I said, we take into account the outcome of the EFSA risk assessment. And I know when I'm following the discussions, of course, this health-based guidance value is always established, taken into account the most vulnerable group. And it is clear that if you would look at another population group, let's say, for instance, at adult people, then you could see that the adverse effects only occur at higher levels, which would consequently, for that adult group, result in a higher health-based guidance value. But as long, and that I might say that quite strongly, is that as long as the EFSA is not providing us the tools by indeed setting different health-based guidance values for different population groups, you cannot expect that the risk manager do take themselves the decision to indeed say, well, for this population group, indeed, there is indeed no problem, they can have it. I must say, I got once from a health practitioner the suggestion saying, well, you are in Europe by your strict levels on mercury in swordfish, wasting a lot of swordfish that is not compliant for human consumption. But this fish with indeed non-compliant levels of mercury can perfectly, you should, and I quote what he said, that's not my words, you could send that to the elderly houses because these people will have much more benefits of the consumption of swordfish than of indeed the potential risks related to the presence of methyl mercury, which is mainly a risk for indeed women in childbearing age and younger population. And I agree with that, but you cannot expect that a risk manager sends non-compliant food to indeed elderly houses because they know that the risks are minimal and they would benefit from the consumption of this food. So we cannot take that decision. Also as regards perception, we have that later on also in this issue that is not possible. And it is the same for these health-based guidance values. As long as indeed EFSA does not set different health-based guidance values for different population groups, you cannot expect the risk manager to take that into account. Thank you.
Thank you, Franz. I see that there are many questions really around this issue of vulnerable population groups. And I think you've answered it more or less. Some of the issues that are being raised here, like susceptible periods of life, like mixtures, like the susceptibility versus vulnerability. I think you've addressed them all from a risk manager's point of view. I think really many of those questions, as you said, are issues for risk assessment. And again, I mean, when there's also a question about, what the policymakers should do, and that is, of course, by far out of our remit here, both as assessors and as managers. But I think the only thing that we can maybe refer to, from my point of view, and I'm sure we will agree, is when it comes to the consumption levels. That, there are certain population groups that consume higher amounts of a certain food, and there your advice is generally pretty clear. I guess am I right, Franz?
Yes. And also I must say, also what I would say is indeed, one of the questions is related here to, in fact, the chemical strategy, indeed, that indeed we have to become stricter in chemical regulation. And how does that comply with the Al-Hara principle? Well, in fact, the point is that we are also the victim of the pollution. And indeed, it is important that we have to much more upfront, indeed, assess the potential risks for indeed presence in the environment and finally presence in in our food supply than before. And we have learned the lesson from indeed the dioxins and the dioxin-like PCBs, where indeed we have it now prohibited already for since many years, and still we are talking about it for our food supply. The same might happen with the forever chemicals, the perfluoroalkyl substances, where indeed now think we are taking quicker measures than in the past for dioxins and dioxin-like PCBs upfront to avoid contamination of the environment, but still we will be confronted in our food chain with, indeed, according to the health-based guidance value established by EFSA for the perfluoroalkyl substance, with unacceptable levels of the PFAS in our food chain. And there, once we are at the food chain, then we have to balance, and that's the ALARA principle, as low as reasonable achievable, to really say, okay, we have to avoid the highest contamination, the hotspots. This cannot enter the food chain. But on the other hand, we have to also ensure that the food still remains available, certainly if it provides nutritional benefits, like the cases is for the fish, where the fish is indeed the victim, the presence of these contaminants in the fish is, the fish has not chosen this, it is because of indeed the fish is living in an environment which has been polluted in the past for that, and where indeed the persistent contaminants remains there for years, decades, maybe sometimes centuries, and indeed affect our food chain for many years.
Okay, thank you, Franz. In view of the time, let me break the discussion here, colleagues. Your questions that you've put on the side maybe will be discussed, of course, in the breakout sessions, some of them. And I see, that there is a kind of a main concern, which is what are the roles of risk assessors and managers in weighing the risk. I think this is really premature to discuss it now. It will be one of the outcomes that we're looking forward to. So Franz, with that, thank you very, very much for your presentation, for being with us and for sharing your experience and which is really wide. So we look forward to discussing with you during the breakout sessions and of course the final session as well. And thank you very, very much.
Okay. Thank you for giving me the possibility to give the risk manager's view.
It's important.
Yeah. Yeah.
Okay. So
Yep.
maybe with that, let's say thank you to Franz and move on to the next presenter, and that is Morten Poulsen, who is a senior researcher at the National Food Institute, which is combined with the Technical University of Denmark since 2015. There, he heads the research group for risk-benefit assessment. This is, of course, really the main issue that we're dealing with today. His research aims at performing quantitative risk-benefit assessments, at assessing the burden of disease, at doing risk ranking, and of course, risk assessment and quantitative health impact assessments. Morten is also a member of the EFSA Novel Food Working Group. So Morten, with that, let me welcome you here and give you the floor to share your expertise and experience. Thank you very much.
Okay, thank you very much. I don't know, can you see the screen? I guess so. Okay, it's good.
Yes, it's there.
Okay, fine, thank you. And first of all, I would like EFSA to take the initiative to arrange this colloquium. I think it's a very nice idea to deal more with risk-benefit assessment. I would say that I have worked with risk-benefit assessment for more than 10 years, and one thing I have learned is that assessing risk and benefits and compare them can be rather simple, but it can also be extremely complicated. In my presentation, I will give you an update on the developments within risk-benefit assessment. I will say something about the current approaches taken within risk-benefit assessment, something about the experience we have gained from that. Then I will give you an example of a risk-benefit assessment we have performed recently in my research group. And then finally, I will inform you of some of the challenges we have met during our work with risk-benefit assessments. Normally, when trying to estimating the health impact of food, we are either focusing on either the risk or the benefits, also included one hazard or one benefits. This can make very good sense, especially in a regulatory setting, for example. However, we also know that food can be associated with both risks and benefits. And in order to compare these benefits and risks, you will need an integrated approach, which we call risk-benefit assessment of foods. And I heard also from the former speaker that this is also the need for coming also from the consumer, Also, that they will need information when we're giving advice on dietary, when we're giving dietary advices. They would like to know the whole picture and knowing about both the benefits and the risks. Risk assessment is multidisciplinary in nature. I think it has also been said before. And therefore, if you're going to make a risk assessment, you will need a team with the expertise within toxicology, microbiology, nutrition, epidemiology, mathematical modeling, chemistry, statistics, and so on. So this can be a rather complicated business, this doing a risk-benefit assessment. I think you probably have seen this before. This is an overall framework of how to do a risk-benefit assessment. This is my own colorful version, but I know that many versions of this exist. And I think the first version I have seen of this was actually in the EFSA guidance paper from 2010. From this picture here, you can also see that risk-benefit assessment is not something exotic. Actually, you can see parts of it resembles mirrors well-known methodologies, like you can see up in the left corner, you can see from the hazard identification going to the hazard characterization, which combined with the exposure gives the risk characterization, which is the risk assessment approach. Similarly, also as is and risk and benefit assessment, we also do the same thing about the benefits. We characterize the benefits in the same steps. Besides this, we also quantify this risk more included in a quantitative way with the risk characterization, where we include information about the risk incidence, duration, mortality of diseases, and so on. Finally, we're able to compare both these risks and benefit into a common health metrics. Even though this seems rather simple going from one box to another, I can say that from each step they will often need a lot of data, and also a lot of decision needs to be taken between the different steps here. This is an illustration of the history of the risk-benefit activities during the last 20 years. As you can see, it started actually one of the first publications I know about was a risk-benefit publication of micronutrients from 2004 by Renwick and Verhaage. This was followed by an EFSA Scientific Colloquium back in 2006, which also led to this guidance document, which we have heard about from 2010. During this period, a number of EU projects were launched within the area of risk-benefit assessment. This was the Bravo, Calibre, Pluribian, and they were quite successful actually in both developed frameworks of how to do a risk-benefit assessment. Also, a number of risk-benefit assessment cases were done within these projects, and also they developed a tool of how to convey health effects into a common health metrics. Later here, there were some Nordic workshops that were arranged, funded by the Nordic Council of Ministers, also by the EFSA. Also by the EFSA code, the workshop in Denmark funded by EFSA, we initiated the European Network for Risk-Benefit Assessment. I'd say recently, EFSA has funded 3 international projects within the area. They have helped with the capacity building, knowledge exchange, but they are also helped to develop to further improve the methodology behind the risk-benefit assessment. What not mentioned here is also that we are currently working together with the WHO to make a policy brief about risk-benefit assessment. And I can see that also what is not in here in this list is all the studies that has been performed during the last 20 years. But as you can see here, this is an overview of the risk-benefit studies that has been performed during the last 20 years. And what strikes you, of course, most is also that the vast majority of these risk-benefit assessments, they have been performed on fish and fish products. And you may wonder why is that? And I think the main reason is, of course, because fish is an important component of our daily diet, but also because fish is such a good example in risk-benefit cases, because it can contain substantial both risks and benefits. You often wonder, and I heard now also EFSA is going to make another assessment, and you wonder why do that? We have already 142 risk-benefit assessment on fish products. Could we just deal with 5 or 10 or so? And this was also what we have asked ourselves also in the network for risk-benefit assessment. And therefore, we decided to initiate a project where we further looked at these different studies to see what were the outcome of the studies and what were the difference in methodology. Did they all use the same methodologies in these studies, or were there differences? This was initiated as a project, and the outcome of this that was published last year as a scoping review with the title Human Health Risk Benefit Assessment of Fish and Other Seafood. This is a quite comprehensive paper with a lot of important information. I have tried to highlight a few of the key findings in this, but there are many key findings, I would say, so it's just a few of them. They were made, there was a big literature review of this with several thousand of studies. Out from this, we made some criteria and ended up with 106 risk-benefit cases published after 2000. Most studies, they made conclusions relevant to the general population, the adult population, or women of childbearing age. Also, the conclusion of these studies were heterogeneous, but mainly there was a consensus that a diet consisting of a variety of different fish and seafood is recommended. In addition, particularly women of childbearing age, pregnant, nursing, and children should limit the consumption of contaminated fish and seafood. As such, this is not a surprise for this, because this is also what we have been told in dietary advices during the last year, so this is not a surprise. Another thing that was perhaps a little bit more surprising from this was that more than 80% of the published studies focused on the richest 15% of the world population. This was also mentioned, highlighted in this paper, saying that what is also needed here in the risk-benefit area are more local risk-benefit assessments. What we also looked at in this study was which components are included in the risk-benefit assessment. What are the endpoints? And this was illustrated with this Sankey plot, where you can see you have the adverse components on the left side and the beneficial components on the right side. What you can see here that the adverse components most often included in these risk-benefit assessment, this was dioxin, methylmercury, inorganic arsenic, lead, and cadmium. Of course, we have also heard this is a looking back, so such things as PFAS and so on, they are not included in this. For the beneficial side, we have the polyunsaturated fatty acids like DHA and EPA, but also selenium. You can also see from these lines between the different components that in most of the studies, comparison was made between the level of dioxin and methylmercury in fish and the level of polyunsaturated fatty acids. One thing that we also were especially interested in this study was also to look at the methodology used in these 106 different risk-benefit assessments. And it showed up, that the majority of the risk-benefit assessment, they estimated the risk and benefits by comparing exposure to nutrition and contaminant with established threshold like the health-based guidance values. This can be quite useful, and it's quick, and you can easily make a screening of the safety of these seafood and fish products. But also it can be a little bit challenging because due to the inherent difference in risk assessment between nutrition and toxicology. Because what you here compare is more threshold values, and you do not compare the genuine adverse effect with the genuine beneficial effects. Other studies, they were grouped. This was the major group, they did it in this way. Smaller group were comparing and integrating risk and benefits in terms of upcoming health metrics, which could be IQ, cancer incidence, mortality, but also due to from a composite health metric as the DALIS, for example. To use this kind of method can be quite useful to compare the effect sizes of potential changes in fish consumption. But also saying that doing this is can be rather troublesome. It's rather comprehensive. It takes some time, and because it takes some time and you need a lot of data, often only few endpoints are included in these studies where DALIs and QALYs are used. I also noticed from the former speaker saying that some member states, they were a little bit doubtful about using the first approach by comparing to the threshold values. And I must agree, I also mostly here tend to focus, I think this we will get more better answers by doing it in a common health metric. Overall, this paper, this scoping review concluded that there was a need for evidence-based, up-to-date and harmonized approaches in the field of risk-benefit assessment. And I think this will probably also what we'll need to discuss during the next days. This is a bravo-tiered approach, and it's also, you could see, we also saw from former speaker, there was it was also inspired from this EFSA guidance document from 2010. It is an approach that can say that also identify how much you need to refine your assessment in order to get to a decision. It first starts with a pre-assessment and problem formulation where you will define the reference scenario, alternative scenario, which you work with in risk-benefit assessment. This we also call the risk-benefit question. Then you go to tier 1. Tier 1 is just to look at whether there's identifiable benefits or risk here. If there are no risk or no benefits, there are no need, it is not a genuine risk-benefit assessment, and we can stop here. If you can identify both risk and benefits, you can go to the tier 2, which is a qualitative integration of these benefits and risks. If you see a clearly dominance by either risk or benefits, you can say, oh, we stop here and we have a decision here by this stage, by this tier. However, if there's no clear dominance of either risk or benefits, you can continue to the quantitative comparison between the risks and the benefits. You can use either a deterministic or a probabilistic approach to do this. Then I think we have heard a lot about theory, and I would like to give you also a practical example of how to do it and a risk-benefit assessment, but more about the data that cover these results that can be obtained from doing a risk-benefit assessment. In this study, which is a few years old, the overall research question was, what is the health impact of increasing the intake of fish in the Danish population? Therefore, we made this a reference scenario, which you can also call control scenario, which was a current intake of fish in the Danish population. We then added 4 alternative scenarios, each with 350 grams per week of a different proportion of either mixed or fatty fish, but also we have one alternative scenario 4 where the 350 grams fish per week was only consisting of tuna. One important thing here is to mention is that when you increase your fish intake, there's something that you also decrease your intake of. Therefore, we decided in this study that the increased fish intake is on behalf of a decreased meat intake. This also means that actually we don't have just one risk-benefit assessment, but we have a combination of a risk-benefit assessment looking at the increased intake of fish, but also a risk-benefit assessment of the decreased intake of meat. When doing these, we often make this, which I have shown here, these risk-benefit diagrams, where we list the food item, we list the components that could be affecting health. Of course, more could also be included here, but this is just an example. From these components, they lead to health effects. You can see either adverse or beneficial health effect illustrated by the green or red line. And from these health effects, we took the relevant health effect and turned them into a common metric. And in this case, the common metric was a composite metric, the disability adjusted life years, the DALIS. this is very short just to say about DALYs. I guess most of you know about these DALYs. Also to say that it's a measurement combining mortality and morbidity. In this case, as you see here, it also in practice, it combines the years lived with a disability together with years of life lost due to early death due to a disease that you die before expected life expectancy. Yes, but back to the results of this. This was the outcome we get when we made these comparison between DALYs between the risks and the benefits from each scenario. And if we take from the bottom, you can see actually there was a lowering of the DALYs, a minus DALYs. And here you must remember that a minus DALY, that is a beneficial, that is a health gain. And if you have a DALYs that is positive, that's a health loss. We could from this see that it was beneficial to increase your fish intake up to the recommended 350 grams per week for the Danish population. And this was seen especially for the mix of lean and fatty fish and for the fatty fish. It was also this smaller increase in the smaller health gain was seen for if you only eat lean fish. What was a little bit surprising for us was that if you only eat tuna, then you actually get a health loss. This health loss was quite prominent. It was corresponding to 8,000 life years in the Danish population each year. You can then wonder what is actually behind these data. What are the endpoints that are actually driving these different DALYs outcomes? What are this driving the health gain and health loss? And we try to also try to estimate that. And as you can see from this is the different scenarios. You can see the 4 different scenarios, alternative scenario we have investigated. And you can see for the first 3, what is driving this health gain, that is the decreased incidence of fatal heart disease caused by this polyunsaturated fatty acids, but also from the decreased incidence of electoral disability caused by the intake of whole fish. Then we was quite interested to see for the tuna, what actually was this due to this health loss we saw. And this was, of course, well, not of course, but you could probably imagine also that this was due to the higher level of methylmercury in the tuna, causing a higher incidence of intellectual disability. But also a little bit surprising, also it was due to a higher incidence of fatal cardiovascular disease caused by the polyunsaturated fatty acids. You must remember this is comparison to this reference to the reference scenario where we also have a mixed intake of both fatty and lean fish. When we look at this, we also think but which of the population group will benefit most from this increased fish intake? Could there be any difference? And actually, we identified 2 population groups which could benefit could be benefit for them to increase their fish intake. One of those was women in the childbearing age, as you can see, between 20 and 40. And the other group that could benefit from it was the middle-aged men above 50. Of course, other groups could also benefit from it, but the main benefit was seen for these 2 population groups. Just something about the challenges we have met when we are doing risk-benefit assessment. I think I have listed here some, but I think I will start with this integration, which are in the bottom of this table, integration in the regulatory system, because this is something we have talked about and a little bit puzzled about, because you could say we have a well-acknowledged method of how to assess risks and benefits. We have tried it and it worked, and we have get good outcome of this, but still it's actually not taken up by the regulatory system. And we are wondering what are the barriers for this. Also, I think looking back at the EFSA guidance document from 2010, it was also meant, I think, more that it should be more embedded in the regulatory system, this risk-benefit assessment, because there you talked about risk-benefit managers and so on, and also this about going up to the first one, this risk-benefit question, this should be made in close collaboration with the risk-benefit manager. I think that is an fully acceptable approach, but the problem is, however, that this risk-benefit manager has been out of office for the last 10 years. So there's not much help there. Also, I would say that one of the challenges we have met is lack of data and knowledge, and also uncertainty. You can say this could also be said for other disciplines like risk assessment. And what will the attempt to do more about this is also about the uncertainty, is try to identify this uncertainty in the different steps of the risk assessment, to characterize them and to make them transparent to the public. Also, what I talked about before about these different ways of assessing the level of evidence, there could be an imbalance because it's more difficult to have a beneficial effect included in the risk-benefit assessment than the risk effects. And this is makes some kind of skewness of this risk-benefit assessment. Because I must also admit, I'm a toxicologist also, and I also tend to, when we have these risk-benefit assessment, we will say, well, we also need a worst case group, and we should also be aware of this worst case. But this is also, you can just say we should also take care of the best case also. But this, I think, is also up for discussion. Substitutions, in the case I just have shown you from our research group, we have actually included substitution, and I think actually it's needed to include substitution in risk-benefit assessment. But even though I think this, when we did this by doing this substitution by also taking into account the meat intake, when also consider the fish intake, this was actually one of the first time it was done in risk-benefit in this risk-benefit study. But I think it's a valid point that this should be taken more up in the risk-benefit assessment area. Then there's this issue about quantitative or qualitative metrics. I think most of it, it's very much depending on actually what data do you have available and what is the question asked to you. Integration of regulatory system, I have talked about that. I will also say that when we are doing risk-benefit assessment, we also often call it a holistic assessment. And what we also are working with is, because we are not trying to focus not only on health in this holistic assessment, but also on other things. Because when you're going to take decisions in the political system, it's not just only health, but it can also be information about sustainability, economy, and so on. And therefore, we try to incorporate more disciplines in this risk-benefit assessment, also try to incorporate sustainability in the risk-benefit assessment, also economy, to get a more overall picture of this. And actually, one of our colleagues have tried to do this. This is an example of trying to combine risk-benefit and sustainability. As you can see here, we have the carbon footprint up at the one axis, and it's not the health impact out of the x-axis. This is the minutes of healthy life lost, and this is just shown by an example by different specific food items. I think it's a quite interesting approach, and I can just leave it for a few seconds as to you can try to place your lunch in this diagram. But I also think, actually think I have used my 20 minutes, so I will stop now. So thank you for your attention.
Thank you very much, Morten. It's in fact, you've used all of your half hour, but that doesn't matter. It was a very interesting presentation, and especially since you addressed a number of issues, like how to deal with, adding the risks on the one side and the benefits on the other together, how to really look at the holistic approach of looking at the benefits of certain food items. But we don't have a lot of time, but maybe I'll prioritize one or two questions. So one question that came very early is actually, how about comparing the adversity of nutrient deficiency versus the adversity of the toxic compounds? So did you look also at the adversity of nutrient deficiency when you did your assessment?
Yes, I would say we have. I would say we have done that. Yes, I would say that it's not difficult for me to just go in detail right now because this means we have to take up the study again. But yes, we have also included that. Yes.
Okay, and I think we'll have time to discuss it in the breakout sessions. I hope you will be with us. And then the other question I might address or take here is, what about bioactive compounds? Were they also considered on the benefit side, or just the nutritional value? Of course, it's, as somebody said here, it depends on how you define bioactive substances.
Yeah, I would say it's very much depending on how you actually define it. But we have tried as best to include these relevant parameters, and we have tried to look at make a brutal list, you can say, overall list of all the parameters that could have an impact. And then we have looked at them and see how much they contribute. And those who have a very small contribution, we have taken them out. So we mainly look at the endpoints, the components that have which have the largest output impact.
Yeah, and I think the most difficult question that I see here, but probably the most important, you may not be able to address it immediately, but maybe during the discussions, is how did you translate hazard and positive health effects seen for various different endpoints into the same metric, in your case into the DELIs, and what data did you use to avoid assumptions that carry large uncertainties? I think it's a very complex question.
Yeah, it's a very complex question. I think I can refer to I think I will more refer to the papers we have made, and we can also share them if needed.
Okay.
I think it will be difficult to answer just right now. Yeah.
But I think if you can bear in mind that, in the breakout session where you are, if this could be,
Yeah, I think it could be a very relevant question. Yes, indeed.
Yeah, absolutely. Yeah. Thank you very much, Morten. So
yes,
maybe,
you're welcome. Yes.
Just not to hold people back from the coffee break, we will thank you very much again for an excellent presentation and also excellent work that you've done, of course, to allow for this presentation. And colleagues, let's break for coffee or tea for half an hour, and we will be back at 16:15 Central European Time. So we'll see you in half an hour. Thank you. Good afternoon, colleagues. I think we can start our post-coffee session. And I can see already that our speaker is there. So welcome to Professor Martin van den Berg. Martin is an emeritus professor of toxicology, recently an emeritus. He used to be the deputy director of the Institute of Risk Assessment Sciences, IRAS, at the University of Utrecht in the Netherlands. And he is actually one of the old hands in modern toxicology. Has been involved in a number of issues, particularly in the work on dioxins and dibenzofurans and other compounds. He's been one of the major advisors of WHO on their work there. Martin is an honorary professor of environmental toxicology at the University of Queensland in Brisbane and a visiting professor at the Royal Chulalongkorn Research Institute in Bangkok. He also received an honorary doctorate from the University of Umeå in Sweden for his work on mixtures of toxicity of dioxin-like compounds. And last but not least, he was president of the Dutch Society of Toxicology between 2010 and 2012. Martin will be speaking to us about the risk-benefit assessment of breastfeeding, an evaluation of WHO and UNEP coordinated exposure studies performed between 1987 and 2019. So Martin, welcome, and the floor is yours.
Thank you. I share the screen and I have a very strong echo. That was interesting. There it is, right? Yeah. But okay, can somebody switch off the echo? Because this is really bad.
So to all the participants, if anybody has not unmuted, muted themselves, please do so.
Maybe it's myself. That's, hold on. let me check. Oh.
Martin, this is from the technical support. Apparently, you are logged in twice. Yes. Maybe I can remove the other.
I put out the AirPods and put it on the speakers, but I still have now I think I don't have an echo anymore.
Okay, perfect.
At least not myself. Yeah. My screen is doing.
I can share the screen for you, if you please.
Well, it's not about the screen, probably. It's
Now for the echo, we
okay.
could have solved it. Okay.
How about now?
We can see it perfectly.
Is it better?
Yes, much better.
Okay.
Thank you.
Yeah, I don't get a. Okay, so thank you very much for giving me the opportunity to present some of the beautiful work which was done by WHO and UNEP together over the last 40 years with respect to the human milk surveys on a global scale. Before I start, usually some of the acknowledgements are made at the end, but I think it's really important to make at least one acknowledgement in the beginning, and that is Rainer Malich. I don't think that this whole work, which we're going to present in different chapters in the handbook, also upcoming about the human milk surveys, couldn't have been done without him and his excellent scientific and chemical analytical expertise. Thanks to him, we know this all. And furthermore, I worked with Van Duursen and Angelica Treacher and Dick Peterson recently about the risk assessment for the breastfed infant. In addition to that, there is a huge number of volunteers which have been working worldwide on the systemic collection of these human milk samples. It's much too much to tell. And actually, the same applies for all the people who are working in laboratories and at WHO over the last 40 years. So I just stick to those 4 persons, but nevertheless, a huge number of people. I have to say thank you, probably on behalf of WHO and UNEP here. There's a small disclaimer. I'm not talking on behalf of WHO or the or UNEP. And in addition to that, Rainer asked me to say that all the data from the European countries have been paid and are courtesy of these countries themselves. Right. So the first evaluation we did with respect to the breastfed infant was done in 2017. And we published it and we looked at the global distribution of human milk concentrations and it's shown here. And what I like to point out to you here is the concentration, because I think this is really important. Here we have the countries with the highest levels of dioxin-like compounds in the human milk. These are dibenzofuran's, dioxins, as well as dioxin-like PCBs. And levels are somewhere between 1 and 30 picograms per gram lipid. Then this is only the period 2000-2010, and we have to realize that if we go back further in time, let's say in the 80s and the 90s, levels must have been maybe 5 to 10 times even higher at the maximum. So levels were extremely high. And when we look at the last round, or the last period, 2 rounds actually involved here, between 2010, 11 and 2019, one of the important things to notice here is that the levels are now roughly a factor 2 lower, somewhere between 1 and 10 picograms per gram lipid in human milk. WHO and UNOP considers human milk an excellent matrix to study, not only with respect to the risks for the breastfed infant, but also to measure actually the efficacy, the efficiency of the remedial actions which are taking place, because these compounds have all been placed on the list of POPs, and worldwide there have been significant reductions in exposure, and especially contamination of food products, pesticides. Combustion processes have become more efficient with lower release of dioxin-like compounds. And so this is actually exact showing the effect of all these remedial actions, but then in a human relevant, highly human relevant parameter. Because what you actually see here is the decrease of the dioxin-like, in this case, the dioxin-like and dibenzofuran-like TEQs, starting somewhere in the 80s and going down all the way in these global milk surveys to somewhere between, let's say, 40 to 50 to between 0 and 5 for the dioxins only. These are not including the dioxin-like PCBs here, meaning that if you want to see a success story in remedial actions, this is an absolute success story over the last 40 years. That doesn't, however, mean that we're already at a level which is be safe. And this is one of the major points we like to address in a paper we're writing right now, and also for this presentation. So these are the PCBs, the dioxins and the dibenzofurans, excluding the PCBs. But if you look at the PCBs, which have also been included in these human milk studies since the 80s, you see basically a kind of similar pattern. And for those of you who really like to go a little bit more in detail, yes, the dioxin-like PCBs following this trend more or less closely. So meaning that we see something like a 80 to 90% decrease over the 40 years that WHO and UNEP has been doing these analyses. And that also means that the systemic exposure, because human milk is a good representation of the systemic exposure of these dioxin-like compounds in humans, have been decreased with almost a factor 90 or sometimes even more. If you put it a little bit better in numbers, then you can see it here, how it actually went down in levels. And here, if you compare the first data coming from round 1, which was somewhere in the middle of the 80s, and you put that at 100%, then you see that over the 40 years to come, and you go down here, it's now almost down to around 15%. If you want to compare it with the beginning of this new century, and you see that, then again, you see still a significant, but a little bit slower trend in going down with the levels of dioxins and PCBs and dioxin-like PCBs. All in all, it looks very good, but we also have to remember that if you look at the individual concentrations for the breastfed infant, that starting from both when the first analysis were done to the present analysis, there's still one order of magnitude difference between individual human milk samples. And that's the same then for the exposure of the breastfed infant. One order of magnitude difference can exist easily for exposure of the breastfed infant to these compounds. Now, risk assessment for dioxin-like compounds for the breastfed infant only. Over the last 30, 40 years, people didn't want to talk about it too much, to tell you the truth. Usually a TMDI, a TWI, a TDI, or whatever it may be, a reference dose, every committee, every organization more or less had to put a little P over it and had its own value. Those were all meant for protection, lifelong exposure. And in this respect, talking about risk of dioxins in breast milk was actually a rather odd one out in normal risk-benefit assessments for example, normal food products. Because this is actually a territory where you get into very, very strong emotions, social, let's say, problems in accepting the fact that there is something in there which isn't good for the breastfed infant. So talking about yes or no breastfeeding was already since the 90s a very difficult topic for a toxicologist to get into. And I rather stayed out of it, but more recently we had so much data and we got so much toxicological information that it's at least worthwhile doing it objectively besides a benefit issue, which is always there. So I'm going to address quickly a number of issues which are relevant for this risk-benefit analysis for the breastfed infant. First of all, can we use the underlying studies for the health-based guidance values from all these different agencies? Can we use relevant human studies for this? Are the present levels still of concern? What's the time course we're looking at over the last 40 years in relation to possible risk for the breastfed infant? And how is the benefit situation? Now, if you put this all in perspective, I think most of the, at least earlier animal studies used these for health-based guidance values. Almost exclusively, there were data used for risk assessment from early life exposure situations. Based, as we know now, and we didn't know that maybe in the 90s, these are all relevant human endpoints for the early life situation, being also based on our knowledge of dioxin-like mechanism of action, the most sensitive life stage. And basically, it doesn't matter that much if you derive an HBGV from direct oral exposure, or you do that when you correct it first for differences in toxicokinetics for humans, because you're looking not at the kinetics, but you're looking at a relevant endpoint at a relevant stage, and then you can correct it if you want to, but you're still looking at data which are not 2-year studies, 90-day studies very often, but very short-term early life stage studies in experimental studies. There's nothing wrong with that, because if you use these HBCs and upgrade them for lifetime exposure, you're at least sure that you will protect the most sensitive life stage. That's the early life stage, starting from the fetus to halfway childhood or something. So if you put them here in a list, here is something that these studies are all animal studies, which are now marked by red, and they've been used in the past or still used to determine a kind of health-based guidance value. Together with some information about how much human milk is consumed, how much lipid there, you can see there's of course exceedance, but you have to realize that all these regulatory agencies often say this is for lifetime protection, not for the breastfed infant only. But you can make a calculation, assuming that the breastfed infant is the most sensitive one, and you end up somewhere in a range. And I'm not going through all these calculations. You can look it up in the publication Archives of Toxicology from 2017. You end up somewhere in a range between 1/10 and 1 picogram per gram lipid milk as being more or less a safe range for the breastfed infant. Now, I'm not going to discuss what is better or not in this case, because to tell you the truth, for dioxins, we just know too much, and it becomes a little bit of mouse milking to say, should it be 0.5, 0.2, or whatever, and I prefer to stay within a range of 0.1 to 1 to look at it. And if we do that, and we take the decline in levels from dioxins, dibenzofurans, and dioxin-like PCBs over the last 40 years, then the green area more or less represents the calculation of a safe level, which we estimate for the breastfed infant. What it actually means, it's somewhere in the range where we think, okay, in this case, with all the knowledge we now have about mechanism of action of dioxin-like compounds, we think that somewhere in the range of 2035 to roughly 2045, we may end up with a level of dioxin-like compounds in breast milk in which we say, from a toxicological point of view, I don't see that much problems anymore, to tell you the truth. Now, honestly, and more recently, both the EPA as well as EFSA have used human data to calculate what is a possible health-based guidance value for these compounds. And it's also an approach. And they used two types of studies for that. And the one thing which is really important from these human health studies is that if they look at the endpoints, they focus on male fertility, in more particular the quality of the semen. And we know from animal studies already in the 90s done by Dick Peterson that especially early life exposure to these type of compounds, also in rodents, does affect the semen quality. So here we have a biological possibility that using these endpoints in human-derived HBGVs is a reasonable approach to use that as an endpoint. So if you look at that, there are two studies involved. One is actually from Moccarelli in the Seveso situation. And the interesting thing for me is that there's always a discussion going on if it is a prenatal effect, both in animals as in humans, or a pre plus postnatal effect, or a postnatal effect only. Well, prenatal effect is clear. We know that from experimental studies very well, but the study from Moccarelli in Seveso and his co-workers actually shows one interesting thing, and that is if we look at actually the formula-fed babies versus the breastfed babies, there is clearly a decrease in quality of the sperm. This is actually the ones which are showing that, yes, there is with breastfeeding some effect, but to tell you the truth, if you include breastfeeding as well as prenatal exposure, the difference becomes even larger. So my main conclusion from this study is from Moccarelli is that both utero as breastfeeding have an effect on the male fertility, which can still be seen later in life. That is obvious. However, there are a number of caveats on this study. For example, it focused mostly on TCD only, because that was the exposure situation in Seveso and doesn't include a complex mixture, which we have as an everyday exposure in the world. And then the levels of the TCD in the mother were extremely high. But nevertheless, male fertility came out as a very sensitive endpoint. There's a Russian study which has been recently taken as an example of how to make a health-based guidance value for dioxin-like compounds, and I have to say only for dioxins and dibenzofurans. And what you see here is actually a similar sensitivity for fertility. However, if you look at this, it confirms what we know with respect to biological plausibility. But the problem is that it's not related to the total amount of TEQs, which includes also some of the dioxin-like PCBs. The concentrations have been measured at 8 and 9 years, by itself not a problem. And one of the things I liked was that EFSA actually made a backwards calculation to estimate what was now a kind of safe level, a NOAL, I think they call it in their report, for the levels of dioxin-like compounds, and those are dioxins and dibenzofurans, in human milk. And if you put that on the same diagram, in which you see the decrease over time, it would be somewhere here, meaning that somewhere around here, a little bit, somewhere between 2030 and 2025, we would end up with a level, on average, I have to say, of dioxins and dibenzofurans in milk, which may be a NOAL, but we still have to take into account a couple of things. First of all, there was no inclusion of the non-dioxin-like PCBs. And secondly, we still have a range of 1 order of magnitude around the average. And this is actually the median. So here we have an area which is about this size. So we will still have individuals which, based on the EFSA calculation, will have a slight risk for some toxicological effects when they are at the upper range of the levels of these type of compounds in human milk, excluding the PCBs actually. And if you would exclude the PCB, the dioxin-like PCBs here, maybe you would see that the level would become a little bit lower, maybe, but I'm not sure. It still has to be determined. Now, Okay, so both studies on semen quality have deficiencies, obviously. But the major difference is that they may not look at everyday exposure situations, complex mixtures, because these are either very high in levels of dioxins or actually one congener only, Seveso, may play an important role. I think that the backward calculation is very important, but what we have to realize, and I take Bradford Hill criteria for this, say, look, there is no study perfect, and Bradford Hill made a lot of criteria, but he also said that it only starts as a serving point for to determine cause-effect relationships. Not hard and fast rules all the time, and there's no complete scientific work. So sticking to a very fixed number here for NOAELs, or a fixed number from the animal studies, the problem with dioxins is we just know too much. We have too much information. So we can look at any data point and we will always see a range. And we should not approach risk assessment only with one fixed number, because it's a bit naive. And if you take it as too much concrete, too much exact data, we're actually doing mouse milking based on a lot of studies which we have available. And we're making decisions, and EFSA does, and a lot of other regulatory agencies is making decisions on a huge number of other chemicals with only a fraction of the information which is available from a toxicological point of view compared with the dioxin-like compounds. We just know too much. However, I think that there are a couple of studies which are very relevant to look at. And those studies are actually comparing breastfeeding with non-breastfeeding in the first 1.5 years. And there are 2 Dutch studies which actually did this, and they did it in the 90s, so the levels were still pretty high, about 5 times higher maybe than now. And we saw effects on the thyroid hormone stimulating levels. In other words, the thyroid hormone homeostasis could be disturbed by the total amount of TEQs. In addition to it, in the same cohorts, they found that there were very, very minor changes in mental developmental index and then the psychomotor developmental index. However, interesting enough was that in these situations, they found out that actually the formula-fed infants had actually a lower score than the ones which are breastfed, meaning that breastfeeding is very good apparently for developing a mental and a psychomotor developmental situation. And that was up to 1.5 years of age. So I think these 2 studies were actually the most representative to say something about differences between giving breastfeeding or not, excluding the prenatal situation. And that is important if you want to talk only about risk for the breastfed infant. My overall conclusions, together with my co-authors, is that although the experimental designs are there for the Dutch cohorts, they're still seeing something which is negative. But they're relatively small, and if you ask a medical doctor how to look at it, he will tell you, or a psychologist, that this is within the normal range. What we don't know for sure is how long in their life this effect will still be present, but for some of the effects we already know that they're transient. So most of the effects seen from this particular Dutch studies, which were most representative when using, for example, the Bradford Hill criteria, then I think they're still within the clinical acceptable range. For a number of them, considered to be transient, probably not for the semen quality studies, which is confirmed later by the 2 studies from Seveso and from Russia. And also there are strong doubts if it's transient for the developmental effects which were seen, and if they don't continue later in life. Now, going benefits directly, the World Health Organization took a position for the last 50 years that breastfeeding is one of the most effective ways to ensure child health and survival. It promotes breastfeeding as the best source for children in early life stage. And if you look at it, and people from EFSA asked me, can you give some more details about the actual beneficiary effects of breastfeeding? They're overwhelming. This is just one of the meta-analysis which was done by the Department of Health in the United States. And what you're actually seeing here is how convincing the benefit is for breastfeeding for children. You got, for example, here, ear infections, and we're looking at an area of a reduction of 25 to 50% of the disease we're talking about. Gastrointestinal infections, asthma, obesity later in life, cardiovascular diseases, ischemic heart diseases later in life, diabetes, leukemia even, and sudden infant death. And they're all somewhere in the range of a reduction of 25 to roughly 50%. And these are approximately 400 epidemiological studies which have been evaluated at the end of 2009. So it's impressive to see the solid information coming for the benefits of breastfeeding compared with the little marginal effects we're seeing in the 90s in, let's say, from an experimental point of view, the best study for everyday exposure of a breastfed infant to the complex mixture which is still present in breastfeeding. Now, the American Dietary Association made a long list of the benefits for the infant. And
Martin, you have 1 minute left, please.
Yeah, 1 minute. I'm almost done. If you see it here, you see a whole list of advantages of breastfeeding for the child. This is a list of benefits for the mother, which is impressive too. And recently it was actually published that if you look at the actual mortality, WHO published in 2015, probably saving 800,000 children. This was confirmed by a publication in The Lancet with almost a similar number, adding additional 20,000 maternal deaths, which would be saved breastfeeding, which is also an impressive, serious number. So altogether, some concluded remarks, and I'll be short here. If you look at the risk-benefit situation of breastfeeding, we're still at levels which we might see some effects, some subtle effects, possibly transient for some children and possible transient for some effects. In general, the positive effects are overwhelming. So if you look at risk-benefit of breastfeeding, I don't think toxicologists can make a serious point out of it that we should limit breastfeeding or whatever, because we're talking about serious benefits, talking about mortality even. So with that, I think I'd like to stop. Thank you very much.
Thank you, Martin. I'm afraid really we've exhausted our time, but maybe there is one urgent burning question. I don't see any in the chat. So those colleagues who are raising their hands, please put any question you have. It should be in the chat. We're not taking any any interventions. Okay, from Silva. Okay, I think there is only one comment here that I can see, that at the time of the evaluation, the infant formula of the study, the infant formula did not have DHA. Is there any comment on that, Martin?
The infant, what didn't it have? Sorry,
the studies in the 90s.
Yeah. I didn't understand. I didn't hear what you say. What wasn't in there?
DHA.
I'm not sure, to tell you the truth. That I don't know.
It's okay. It is this docosahexaenoic acid. Okay, so maybe Martin, I hope that you will be with us tomorrow during the breakout sessions, and then we can discuss those, or at least at the final session. But thank you very much for your presentation, for being here. And I will, just really being conscious of the time, we'll move on to the next presentation, which is by Dr. Walter Willett on trends and developments in the assessment of nutritional health benefits of the consumption of foods. Professor Willett is a physician and epidemiologist. He's professor of epidemiology and nutrition at the Harvard T.H. Chan School of Public Health, where he was chair of the Department of Nutrition for more than 25 years. Much of his work has been actually on the development of methods using both questionnaires and biochemical approaches to study the effects of diet on the occurrence of major diseases. And he has, of course, applied these methods in several major studies, particularly nurses' health studies and the health professionals follow-up study. And these actually contained a large number of participants, 300 men and women, with repeated dietary assessments. So actually, a large experience. He has more than 2,000 research papers, primarily on lifestyle risk factors for heart disease and cancer. And he has written the major textbook, which is Nutritional Epidemiology. So he's really one of the, should I say, one of the most renowned experts in the field, and we're happy to have him with us. He's a member of the National Academy of Medicine and a recipient of many national and international awards for his research. So, Professor Willett, let me please ask you to take the floor and welcome you again.
Okay, nice to be with you. And I greatly appreciate the fact that EFSA is taking on this challenge of looking deeply at the risks and benefits of foods. In fact, I wish our own FDA was paying attention to this, because they seem fixated on micronutrients and really not paying attention to the overwhelming poor quality of the American diet. I think you're going to control the slides, so I'll ask if the first one could go up. And I'll just request next as we go along. Great. You can go on to the next slide, please. That the study of, no, backwards, one slide. Yes, studies of health effects of specific foods pose many challenges. First of all, if we're looking at diseases like cancer and cardiovascular disease, the major causes of poor health, the lags between intake and the disease can be decades, but it can also be quite short. So there's a whole range of possible latencies. The range of intake in any population may be limited. For example, we in the West can't look at high intakes of soy products very well, but in some Eastern countries, they can't look at red meat very well. So it's really valuable to put together information globally. Also, if we're looking at single foods, the effects are likely to be small, because that's only one part of the contribution of many foods in the diet. Intakes of one food may be correlated with other intakes of other foods, so there could be confounding among foods, and there can also be confounding, of course, by non-dietary factors. Long-term randomized trials, usually the gold standard, are usually not feasible for reasons we'll come back to. Next slide, please. So how do we address these challenges? Next slide there. Primarily, I think we are dependent on long-term prospective cohort studies, and that raises a question that I'll come back to about how we assess diet. Biomarkers can be used as outcomes sometimes, and those could include surrogate outcomes like blood pressure and blood lipids, which can be studied in short-term intervention studies, trials that last a few weeks and need to include only a few dozen participants. We can sometimes use animal studies, but again, that has major limitations in generalizing from them to humans. A lot of work is being done in nutrient profiling of foods, but that, of course, doesn't provide the full impact of the healthfulness of a food, because there are hundreds of other constituents that may have negative or positive effects. Probably the most important, and my conclusion will be this, that combinations of the above will be our best way to assess the healthfulness, the risks and the harms of specific foods, and particularly the combination of long-term cohort studies along with randomized trials with surrogate endpoints where possible. Next slide. Next, please. I'm going to spend a couple of minutes talking about the issues of dietary assessment. we fortunately received funding to do a quite expensive validation study looking at different methods of dietary assessment in men and women. Each study was about 620 people. This is the basic design. We had at the beginning of the year standard food frequency questionnaire, semi-quantitative food frequency questionnaire, and that was repeated 1 year later. Next slide. I just hit the button once. And during that year, we collected 2 1-week weighed diet records, carefully weighed and measured. Next slide. And also during that year, we collected 4 24-hour online recalls of the previous 24 hours of food intake. Next slide, please. And at the same time, we collected 4 24-hour urine samples. Next, please. And 2 fasting blood samples. So that gave us a tremendous possibility of comparing different methods of dietary assessment, including the 3 most commonly used dietary intake assessment methods and a range of biomarkers. We spaced these out carefully in time so we didn't collect short-term biomarkers and short-term dietary intake methods at the same time. Next, please. This has provided a lot of data, some of it published just a few weeks ago. Boiling a lot of data down, the 2 columns or 2 data points on the left are the average correlations for 43 common nutrients between the food frequency questionnaire and the weighed diet records, that 0.63 and then 0.62 when the comparison was the 24-hour recalls, which we consider reasonable validity. In epidemiologic studies, we usually want to be above 4.0, but of course, we're rarely going to get from a single assessment something as high as 0.8 or 0.9. Next, please. Next. Okay. What we were able to do, I think really for the first time, is to directly compare the validity of these different methods of assessment using a biomarker as the reference method. The biomarker, not perfect itself, but if we compare each one of the methods with the biomarker, looking at the correlations of each one with a biomarker, this will give us an indication of the relative validity of the different dietary intake assessment methods. The 3 main ones being, again, 24-hour recall, food frequency questionnaire, and 7-day weighed diet record. Next, please. This slide, the next one, will show the sampling of results here. I think the probably most representative here is over on the right, beta carotene here, which has a fair amount of day-to-day variation. And there's no question that 2 weeks of weighed diet records would be best. That's the column on the right, with a correlation of 0.58 between the dietary intake of beta carotene and the blood measurement of beta carotene. And the blue column next to it is 1 week of weighed diet record, not too much lower correlation than the 2 weeks. And then the food frequency questionnaire does about as well as the 1 week of weighed diet record. But the food frequency questionnaire costs about 1/1000th of the cost of the weighed diet record and has a much lower burden for the participant. So there's roughly similar validity, I think, overall between the food frequency questionnaire and the 1 week weighed diet record, but vastly lower cost and burden for the food frequency questionnaire. Next to beta carotene, there is long chain omega-3 fatty acids. We don't go on. We can go back to the previous slide. The long chain omega-3 fatty acid is a pretty good representation of fish intake, but of course we do get some from elongation of alpha-linolenic acid, which is from plants. So it's not a perfect representation of fish intake. But in some ways, this is these are looking at nutrients here, not specific foods in general, except this is, again, close to a specific food. And here, with a food that's more episodic, there the food frequency questionnaire does just as well, maybe if anything slightly better than the weighed diet record. But for all of these, the worst, of course, is a single 24-hour recall. And on the left, are the dark blue, and the 4 days of 24-hour recall. It still does quite poorly. And again, the cost in terms of participant burden there is really quite substantial. And so it's really for this kind of reason that in long-term large epidemiologic studies, virtually everyone has gravitated toward using the food frequency questionnaire as the primary method of data collection. And because it's inexpensive and low cost, it can be repeated over time, which I'll come back to is very important. Next, please. Next slide, please. Yeah, this is looking at the validity of specific foods, comparing the questionnaire to weighed diet records, the gold standard. There is, we're quite aware, some bias that people do tend to overreport their intake of foods that are generally deemed to be socially desirable and underreport foods that are less socially desirable. And you can see that there in the first two lines there, looking at the number of servings per day. Skim and low-fat milk are overreported on the questionnaire compared to the diet record, and whole-fat milk is a little underreported compared to the diet record. And we see, not in this slide, but looking at all the data, that fruits and vegetables tend to be overreported somewhat, and foods like cream or butter tend to be underreported. Over on the right-hand column are the correlations that have been de-attenuated for variability in the comparison method. And you can see the correlations are actually pretty good for almost all of the foods that we've looked at on the questionnaire. There are a few that are lower, and they tend to be the foods that are rarely consumed. Next slide, please. So we do have reasonable assessment. This is looking back at nutrients, not specific foods. And I should say that very fewer studies have looked at the validity of foods versus those that have looked at nutrients. There's a lot more analytic work that needs to be done to look at foods. And for that reason, I think most people haven't taken the steps to do that. This is making the point that we get more greater validity by taking repeated measurements over time. We're really trying to estimate long-term intake of foods and nutrients in our study. If we look at the last column here, this gives us the average of 3 food frequency questionnaires conducted over a 6-year period, and then the average over the number of nutrients here down at the bottom. If we correct for within-person variability in the diet records, the reference here, the validity is 0.83. So we're getting, with average of 3 questionnaires, we are getting up to really quite high validity for assessing long-term intake, which is really what we want to know. Next slide, please. We've applied these methods to our large cohort studies, and I just should mention there are many people who contributed to this work, and I've listed some of the names at the bottom, but there are many more too. This is really a team effort. The first study, Nurses' Health Study, being 121,000 women that we've been following and are still following since 1976. And since 1986, we've been collecting dietary intake every 4 years using this method. And of course, collecting data on covariates like smoking and physical activity and medical history to take those into account in the analysis. We added 52,000 men in 1986 and another 116,000 women in 1989, recognizing that we needed to look earlier in life. These are quite young adult women when they were enrolled. Next slide, please. And those repeated measurements have been extremely important. You can see at the left, this is looking at type of fat and total mortality. The horizontal axis is increasing percentage of energy from specific types of fat. We see a strong increase, the blue line there for trans fat, the red for saturated fat, monounsaturated fat inverse, and polyunsaturated fat strongly inverse. And that's using what we call the cumulative average of all the questionnaires up to the start of each 2-year interval, and then prospectively during that 2-year interval. But if we only had the baseline measurement at the right is what we would see. And as you can appreciate, we would have missed almost everything if we had only had the baseline measurement. So the repeated measurements are really important in long-term studies. Next slide, please. One other important point is that if we are talking about whether a food is positively healthy or has negative health effects, it really depends on the comparison. Because our total energy is more or less fixed for an individual, we have to make changes. If we're going to increase one food, we're going to have to decrease something else. And so this is just to make the point, looking at total mortality here for different sources of protein with the same percentage of energy from protein, 3%. That horizontal line is dairy. So is dairy good for us or bad for us? Well, it depends on what the comparison. If it's processed meat, we'd be better off in terms of all-cause mortality having dairy. But if we compare dairy to plant protein sources like nuts, beans, and soy products, we'd be better off having more of those plant sources of protein replacing dairy. So virtually everything is relative here, and that's an important point. I think we get into a lot of confusion not being specific about the comparison. Next slide, please. Of course, when we're assessing the overall health benefit, the endpoint is critical here. Do we look at cancer or cardiovascular disease? I think we do need to look at specific outcomes or types of cancer or subtypes of cancer even to really look and understand fully what the health implications of a food are. But it's also important to have some summary. Often total mortality is used, but in fact, that's one of the most difficult outcomes to study because the causes of death may actually have been operating decades before someone died of the complications of the underlying disease. And so we've often used what we call major or total chronic disease, which includes all forms of cardiovascular disease, cancer, diabetes, and death from any other cause except trauma. And so this is just one study, but that is, I think, a useful sort of summary endpoint, but also the specific endpoints are important as well. Next slide, please. In addition to the epidemiologic studies, as I mentioned, randomized intervention studies with important risk factors or intermediate variables are extremely valuable here. This is looking at randomized trials. This is a meta-analysis of about 24 controlled feeding studies looking at red meat in relation to LDL cholesterol, obviously a salient endpoint. And here again, the comparison is important. If we look at red meat just in relation to usual diet or other animal proteins, we don't see much effect. But if we look at red meat compared to high quality plant proteins like legumes, soy, and nuts, then there's a clear adverse effect of red meat on LDL cholesterol. So that in combination with seeing red meat associated with risk of coronary heart disease does make a strong conclusion that there is very likely a causal relationship between high red meat consumption compared to healthy plant-based protein studies with coronary heart disease as the endpoint. Next slide. Some of our colleagues in Germany have taken this kind of meta-analysis, the next step, what they call a network meta-analysis that combines 66 randomized trials of different food groups and then looking at a whole array of cardiovascular risk factors here related to lipids, blood pressure, insulin resistance, and inflammation. And then converting that into a score, they were able to rank different foods according to their relationship to cardiometabolic disease. And in terms of healthfulness, nuts came out on top, legumes, whole grains being best, fish, fruits and vegetables being good, and then starting to get into foods with really less healthy outcomes, refined grains, red meat, eggs, dairy, and sugar-sweetened beverages, which is very, very consistent with the slide I showed you looking at all-cause mortality. So again, I think this coherence between these kind of randomized studies and the long-term epidemiologic studies does create a strong evidence base for considering risk and benefits. Next, please. Recently, just a few weeks ago, our colleagues over at Tufts published a summary of analyses of this type, looking at different foods and using the Bradford Hill criteria to reach either probable or convincing evidence of causal associations. And I won't go into all the details here, but in terms of protection, they came up with fruits, vegetables, nuts and seeds, whole grains, fish or seafood, yogurt, chocolate, milk, and tea. Then they got into nutrients. Again, very similar to what I showed you earlier. There are limitations, though, that fruits are a very broad category, as are vegetables, and we really like to have greater specificity. So, but yet they were able to draw quite, I think, strong conclusions based on this combination of evidence. Next study. They also looked at, next slide, please. They also looked at harmful effects, and their potatoes, red meat, processed meat, sugar sweetened beverages. Again, very consistent with what I just showed. So I think there is now quite a strong body of evidence where we can at least look at the big picture of foods that are likely to be harmful and those that are likely to be healthy. Again, keeping in mind it's all relative. Next, please. What about biomarkers? They can provide some very useful information for some aspects of foods that we can't measure very well, but they also have great limitations. They may not, many biomarkers are not very sensitive to intake. Most of them are not very time integrated, which is important for non-communicable disease. They're often expensive, especially if you want to measure a wide array of dietary factors. For many, I think most nutrients, they're actually not available. Even though we can measure sodium, for example, very well in the blood, it doesn't reflect sodium intake. And very few cohorts have multiple blood samples. So even if we had a really good biomarker at one point in time, it may not be good for the long time. It's even more problematic looking at 24-hour urines, and very few cohorts have multiple 24-hour urines. We actually published a paper a few months ago in the New England Journal of Medicine looking at sodium intake and trying to pull together all the studies we could find around the world that had multiple 24-hour urines. And we could only find all the studies combined, only 11,000 participants. So even though we can do a lot of good measurements, we have the technology in 24-hour urines, the basic samples aren't there. Next slide, please. And we do have a few examples where we have food-specific biomarkers. I mentioned fish and omega-3 fatty acids, not totally specific. One of the poster children is for citrus fruits coming out of metabolomic analyses. Proline betaine is fairly specific to citrus fruits, but even then it's not specific enough because you'd really want to know the difference between grapefruit and oranges, and it can't make that distinction. And they have very different biological effects. Pepper, there's a pepperine. We can pick up dairy fat measured by odd chain saturated fatty acids. But again, there's some, it turns out not so good, even though it's almost all from dairy foods, but it's metabolized. And there are some other sources. Soy, genistein, we can measure, but that has a short half-life. And if you have it every day or multiple times every day, it can work pretty well. Otherwise, if it's episodic consumption, we can't measure it very well because of the short half-life. But whenever we do want to use a biomarker, it really is important to assess the validity and the relative validity, as I demonstrated earlier, especially compared to existing methods such as questionnaires, looking at the within-person variability and comparisons with diet records or feeding studies. There's a lot of enthusiasm, there's been a lot of enthusiasm for decades for biomarkers, but the reality is we still have very few food-specific biomarkers. Even though they may be expensive for a big study, they can be useful in validation studies as the outcome sometimes, and they can be useful in combination with intake data, such as plasma carotenoid levels and carrot intake. And the next slide, please. I'll just use an example here that in our large cohort studies, this is about with 11,000 incident cases of breast cancer over 3 decades. Next slide, please. We do see that dark orange vegetables, including carrots and winter squash, are related to lower risk of breast cancer, and particularly estrogen receptor negative breast cancer. Next slide, please. Also, we have data from a polling project led by Dr. Eliason that, especially for ER negative breast cancer, there's a strong inverse relationship between blood levels of beta carotene and risk of breast cancer. So that combination of biomarker-based and food-based questionnaires does provide, I think, quite strong evidence that there is likely a causal relationship between inverse relationship between carrot consumption and estrogen receptor negative breast cancer. Next slide, please. We also, in the same analysis, see a relationship, next please, between cruciferous vegetables and an inverse relationship with breast cancer, but we don't have good biomarker data that we've been able to find that had good half-life. And so we don't have comparable data, which would be quite useful. But I think there is the consistency of the different types of cruciferous vegetables and inverse relationship there for broccoli, cabbage, cauliflower does make a quite strong case that there's likely to be a relationship. And it's consistent with a lot of animal studies as well. Next slide, please. Even though fruits and vegetables are clearly as a group beneficial, I think we do have to keep our minds open to the possibility that there could be some harms. For example, this is looking at a pooled analysis of pancreatic cancer, and there are some positive associations there, especially for Brussels sprouts. And these foods do contain very potent enzyme-inducing compounds that in animal studies sometimes increase cancer, sometimes decrease cancer. Or is it possible that this relates to pesticides that are used for Brussels sprouts? Or is it due to chance? And unfortunately, this contains all the world's data at that point, but we do have enough follow-up now. We really should take a look at this again. I think chance is still a possibility here. But mainly, I think, again, we do need to do a deep look at specific vegetables. They're not all the same. They're just extremely different in their composition. Next slide, please.
Walter, 1 minute, please.
Okay, yeah. So why don't we skip this one? I was just going to make the point that adducts can be very, biomarkers of adducts can be very helpful. Next slide, please. Yes, it's faster when I move on myself. Sorry. Here's randomized trials. Again, I think everybody appreciates it's really not very feasible for specific foods. It may take decades keeping people on diets when you have tens of thousands of people, and supplements are not going to represent the foods very well. Next slide, please. Again, the point that we need for using biomarkers in urine samples, we need multiple days. Very few studies have them. Next slide, please. So I would encourage that people designing studies and funders encourage the funding of studies that do collect multiple 24-hour urine samples. There's a lot we could measure in them, but the technology has gone way beyond the availability of biological samples. So to summarize, no single approach exists for assessing the health effects of specific foods. The best evidence will often derive from prospective cohort studies of diet combined with short-term trials using intermediate factors as outcomes. Biomarkers alone will rarely be sufficient, but they can play a supporting role. Thank you.
Okay, thank you very much, Walter. It was really a very comprehensive presentation and I particularly liked the fact that, you highlighted the need to look at various, various approaches. You cannot take one approach for itself, but because, people are talking about biomarkers being, the solution to everything. They're not, of course. Maybe we can take one question that which is, do you think that the rationale used in setting tools for nutrient profiling of foods, like scores taking into account beneficial nutrients and so on, and potentially harmful nutrients like sodium, could be helpful for the risk-benefit assessment of combined exposure to nutrients and contaminants?
Yes, I think there's some room for that. It's not complete because I think we all appreciate that sort of finite list of factors that goes into nutrient profiling. It doesn't capture all of the hundreds of phytochemicals that are in foods and their interactions. So it's likely to be incomplete, but it's a first order approximation. And we did actually use what I think is the most comprehensive nutrient profiling system. I'm not sure if you're familiar with it. It's the ONCI system, the Overall Nutrient Quality Index that David Katz developed. And we applied that to our cohort data so we could score people's whole diets by their ONCI score. And it did predict better health outcomes. So in some ways, that is a validation. It did identify healthier foods. Unfortunately, the supermarket giants squashed the application of this. Basically, they didn't want consumers to know this information. And so it's not really available. A few stores started it, but basically they were pressured by the food industry to remove it. So there's heavy duty pushback, and when you get to something that really is giving you some a bright light on what foods contain.
Okay, thank you very much, Walter. I think we'll have a lot of discussion with you during at least the breakout sessions and afterwards. I hope you'll be with us.
Yeah, I'm not sure I can. If I can't, I'd be happy to take some email questions.
Excellent. Okay, but anyway, we'll need your expertise for sure. Thank you very much. And with that, again, it's about time, so I'm afraid, we'll have to break it. It could be a nice long discussion with you, in fact. But I will, stop here. And thank you very much again, and move on to the next speakers, and that is Wim Baker, who is a full professor of agro-food marketing and consumer behavior at the Department of Agricultural Economics at Ghent University in Belgium. Wim is involved in academic teaching and research in the domains of economics, food marketing, market research, and consumer behavior. And he deals in his research with food consumer science, stakeholder and consumer decision-making, perception and acceptance of agriculture and food production technologies, and food products or product concepts, as well as the impact of information and communication about food quality and safety on people's attitudes as citizens and as their behavior as consumers. So I think it's really welcome to have a leading social scientist with us to introduce this area, and he will speak about the influence of trust and perceptions of risk and benefits of consumption of food, the needs from a consumer point of view in relation to dietary advice. So with that, Wim, the floor is yours.
Thank you very much, Mr. Chairman. I already started sharing my screen, so I hope you can see it and hear me all right. Thanks, ladies and gentlemen, for staying with us until the very last presentation of this very interesting but also long afternoon. So to start with, as a kind of context to my contribution here, I will say a few words about growing expectations that consumers have related to food, the multitude of factors that shape their food choices, and then by using some empirical studies, I will point at the power of negative publicity shaping risk perceptions. We will look also at response strategies, policy expectations that consumers have when facing uncertainty or risk in relation to food choice. And finally, also a few words about the potential of social media in risk-benefit communication. First, consumers' expectations from food production and food products. They have been gradually growing if we look at the past 25 years, with emerging issues, starting with safety, end of the 90s, but then health became more important, environment friendliness became important. Then we saw sustainability being added to this growing amount of expectations. And altogether, consumers are still very keen on tasty food and also affordable food. So there's really a lot on their agenda. And they also expect reassurance about these attributes and food qualities, not only during the stages of food purchase and consumption, but basically at any moment that may suit them. So they really want this information to be available. They are not necessarily going to seek it or use it, but availability is important. And when they want it, they want to have access to information that reassures them. Consumers' food choices are determined by a large number of factors, starting with personal determinants, including two of the focal themes of today's presentation, namely risk and benefit perceptions, but also trust. Next to this, there are a lot of environmental determinants that influence food choices, including macro environmental factors like technological evolutions, political decisions, regulatory frameworks, but also micro environmental factors that relate to the producers, the processors, the retailers and the distribution sector. All these factors interplay and determine consumers' food choices. So it becomes really a complex picture to fully understand it. As a first empirical research, I would like to share here some insights from a study where we measured consumer responses to health risk-benefit information regarding seafood consumption. Within this study, people were exposed to different messages. The context was not only risk-benefit information, but also sustainability information. And we had multiple messages like the ones that are shown here, pointing first to the nutrients, the beneficial nutrients of fish consumption, but also explicitly referring to possible risk factors and also to possible contaminants. And we also spoke about the importance of choosing seafood with an eco label. In another message condition, we spoke about seafood choice within the season and so on. But here, for the sake of this presentation, let's focus on that risk-benefit component. We measured consumers' risk perceptions and benefit perceptions before exposure to the message, and we repeated that after exposure to this message. And the results that you see here on the left-hand side, risk perception pre and post-exposure. So the lighter color is always the pre, the darker is the post-exposure measurement, and on the right-hand side, benefit perception. This study sample consisted of 5 different groups of consumers, CL1 to CL5. There were 5 clusters that we identified, and they were identified based on their intention to increase or change seafood consumption as well as sustainable seafood choice. Just to give you an idea, the largest number here, largest cluster was number 1, consisting of 60% of the study sample. And cluster 4, for example, was a very small one, 5% of the study sample. First thing we see is that exposure to the message increased risk perception in all the study samples and in all the clusters. Exposure to the message, on the other hand, decreased in some cases benefit perception, but the decrease that we saw over here was not as large as the increase we saw in risk perception. That's also plausible because benefit perception was already very strong, exceeding 6 on a 7-point scale in many of those clusters before exposure. So there is basically not a lot of room for further improvement. Logically, you would expect some decrease. However, if we look then at the intention to eat seafood following exposure to this message. Only in one of the clusters we saw a decrease. All the others planned to maintain or even increase their seafood consumption after being exposed to a balanced information message that pointed both at risks and benefits. So only in a very small segment here of this study population, we saw an intention to decrease. And that led actually then to a conclusion that the study indicated that a large majority of consumers are not necessarily scared off because of the provided information, including both health risk and health benefit components. And that's also what has been mentioned at the beginning of this afternoon by our chairman when pointing at consumers want to see the full picture. Well, this is indeed indicating that they are not necessarily scared off by the full picture. In this study, at least. However, there have been other times when we look back to, for example, the end of the 90s. Especially this was a study based on data from Belgium, longitudinal data, where we had some history of growth hormone abuse in the beef production sector. We also had, of course, BSE, and we had dioxins. And when we looked at the response of consumers in terms of what the amount of beef they eat, they responded favorably to generic advertising, and that's indicated with the blue curve here. But they responded negatively, obviously, to negative press. And the more negative press we saw, from low levels to high levels, the more negative that response was. So beef expenditure shares decreased. When we look at the slopes of those two curves, we see a ratio of 5:1, which basically means that 5 expensive units of positive news are needed to balance the impact of 1 unit of negative press that comes for free, that works very fast, and that also has a long carryover, which means that people tend to respond it for a long time. So this is a study based on data from the end of the 90s, and actually this was also one of the triggers that led finally to that EU General Food Law that has also been mentioned already earlier this afternoon, and also the establishment of EFSA. So basically, without this event, we would not have our event today, eventually. Looking at a more recent case, cultured meat, for example, which is presenting itself as a very promising alternative to conventional meat. We measured consumers' intention to or acceptance basically of the concept of cultured meat, and we looked at the impact of motives as well as the impact of perceived barriers. And among the motives among consumers, we saw animal welfare, food security, and environmental sustainability as being the most important motives that may contribute to accepting this new product concept. The graph here indicates the probability of being willing to eat cultured meat depending on the strength of motives. And from this graph immediately we can see that the motives have to be quite strong for moving consumers really to a high level of acceptance. For example, to reach an acceptance of 50%, motives have to be very strong. The flip side of the coin is perceived barriers. And here we see exactly the opposite. The stronger the perceived barriers, the lower the acceptance or the willingness to accept this cultured meat. And among the barriers, the most predominant ones were not natural, not real, and no trust. The main message, however, is, again, if we look at the ratio of the impact of motives versus barriers. And we can do that by comparing the odds ratios. The odds ratio for motives was 16 in the analysis, and the odds ratio for perceived barriers was 0.03. And the reciprocal of that is 33, which means that here we obtain a ratio of 2 to 1. And where barrier perception, where trust is a main issue, has double the impact of motives perceptions, which is the positive side of the coin. A question is, how can we inform consumers? And can we do that eventually by putting more information on food labels? And I'm often using this picture here of a crossroad in Ghent as a kind of metaphor indicating what may happen in cases of information overload that yields uncertainty. Basically, consumers have the following possible response strategies. The easiest for them is, of course, to ignore the information. That's easy, that's convenient, and that's also happening with a lot of food choices, because food choices for many people are low involvement choices, and they are not extremely important if there are no particular risks or uncertainties. So for a majority, ignoring the information may provide a solution. Others may process the information systematically. However, that requires a high degree of involvement. That's typically the case, for example, with consumers facing allergies, and they will indeed scrutinize product labels, and they will seek for additional information if they are not certain. Others may seek and use easy decision rules, which are also called heuristics in consumer science. For example, here on the left-hand side picture, there is a car in front of us that manages to cross the street. Well, we could simply follow that car and we rely on it. And that's an easy decision rule. This strategy is explaining the success of brands and quality labels in some cases. And finally, consumers may also seek and avoid an alternative route and simply avoid this crossroad in the future. That means that they switch to more trusted substitutes. From a food marketeer's perspective, of course, this is quite dramatic if you lose customers because of this response strategy. Now, let's go back to the case of seafood. We performed a study here within the framework of 2 European funded projects, EC Safe Seafood and Seafood Tomorrow, where we looked at consumers' acceptance of an online tool that provides them with personalized risk-benefit information about seafood. The tool is called Fish Choice. It has been developed by colleagues in Spain from the University of Rovira i Virgili, led by our colleague, Professor Jose Domingo. And people can enter their seafood choice in this tool, and then they receive information about the nutrients that this will bring them, as well as the contaminants. And recently, the tool has also been extended with information about sustainability aspects. The tool is available in 25 EU languages, and so can be used by consumers. The involvement of my research group in this project was that we measured consumers' reactions when being first exposed to this tool. And for example, here, if we look at different countries, first impressions were very positive in Spain, very positive in Portugal. They were the least positive in Belgium, where 25% of the study sample indicated to be rather negative. And the gradient we observe here fits nicely with seafood consumption, because from the 5 countries included here, indeed, seafood consumption is highest in Spain and Portugal, lowest in Belgium. And when we look at the same data, but now by seafood consumption frequency, that's indeed confirmed. The heavy users of seafood had the most positive first impressions with respect to this kind of tool, providing them with personalized risk-benefit information. Overall, in the study sample, the attitude of consumers as well as their intention to use were quite favorable, with a mean score of more than 5 on a 7-point scale. This was promising with respect to the future of tools like this one that can provide consumers with personalized risk-benefit information. In another study, we looked at consumers' reactions when facing an incident. And in this case, it was the horse meat incident from 2013. This was a qualitative study where we used an online deliberation tool where consumers could provide comments, ask questions, and it was like a chat, and we analyzed the contents of everything that consumers indicated in that chat. It was done in UK and Ireland, and the findings are indicated here. So first, people felt betrayed. They were surprised by the length and the complexity of the food chain. They lowered their expectations about the quality of processed meat, and they indicated to be concerned about the health impact of residues. Their response strategies were grouped into personal response strategies, but also expectations with respect to the food industry and authorities. They demanded more accountability, implementation of penalties, more information and transparency, incentives to source products more locally, addressing low prices of food, and also initiatives that would trigger and facilitate the use of labels, quality labels, for example. With respect to personal behavioral strategies, consumers indicated to be more aware of food choices and decisions, to choose more carefully where to purchase food, to change their frequency, rate of consumption, and also to change their cooking methods. In this case, for example, they indicated that they would prepare their lasagna themselves rather than purchase a processed lasagna, as an example here in this context. In a similar study, but this time in Belgium and more recently, we asked consumers to what extent they perceive food products to be sensitive to adulteration or fraud. And the products that were included in the survey, they are ranked here from lowest sensitivity to highest perceived sensitivity, from left top to bottom right. So local foods and food products from short supply channels, they were perceived as being the least sensitive to fraud and adulteration, and then the opposite, processed imported food products from a non-EU origin, they were perceived to be the most sensitive. What's interesting here is first to look at that divide between fresh and processed. So each time we see that processed food products were perceived by consumers as being more sensitive than fresh. And then also a very interesting one in the context of today's setting is certainly also the difference between EU origin and non-EU origin. So products from a non-EU origin, and especially if they were processed, they were perceived to be most sensitive and raising most uncertainties among consumers in this context. Again, we asked people about their response strategies, and the consumers indicated to pay more attention to quality labels, more attention to label in general on food products, again, buying more local, and becoming more careful when purchasing food. And in a similar vein as with the horse meat study, we asked about consumers' expected policy response strategies. The top three there, again, had to do with local sourcing, more correct food prices, which is actually what we are going to face in the next year, probably as a consumer. So I'm curious to see whether people will still be very, very fond of that. And also, again, they ask for offenders being more severely punished. But what's interesting from a policy perspective is especially those that are now highlighted. So consumers expect more communication, they expect faster communication, more transparency, and more efforts to exchange information, both within the food supply chain and with consumers in the end. Finally, last point I would like to quickly introduce here is the potential of social versus traditional media in risk-benefit communication. In a series of studies within the EU-funded project Food Risk, we looked at the potential of social media. And for example, here in this first study, we identified key challenges to successfully incorporate social media in future risk-benefit communication strategies. In another study, we identified the SWOT components of social media in the context again of food risk and benefit communication, based on interviews and a strategic orientation around study with stakeholders and experts in different EU countries. Furthermore, we try to identify and profile consumer segments based on their interest in using social media to obtain information about the risks here, specifically of pesticide residues. And this study made it clear that with respect to social media, consumers appreciated the speed and the accessibility as the main assets of this media, but they also indicated a lack of trustworthiness as a main perceived barrier for using social media in this context of risk communication. Finally, a last study here where we also looked at different consumer segments and studied their inclination to use traditional online or social media in the context of food-related risks. And the conclusion here was that social media are not a substitute for traditional or online media, but may complement the other channels. And especially that social media is also appealing to a particular consumer segment that was profiled as people who are very keen on being well informed, people who are more motivated to seek information rather than to simply receive information. Also people who are more sensitive to risks in general, and people who perceive a higher likelihood of food safety incidents to occur. So a very particular consumer segment can be reached in addition by means of social media in a risk-benefit communication context. So that brings me to my conclusions or take-home messages from some selected insights that I shared with you from empirical consumer research, which hopefully has underscored the importance of risk communication and also the role and potential contributions of social and communication sciences. First point, high expectations related to food among consumers, indeed including the full picture. Consumers want to have access to the full picture. Second, their food choices are determined by a multitude of factors, not only by risk and benefit perceptions or trust, but many other factors contribute to that very complex decision making. It has been shown that consumers can deal with risk-benefit information and also that they are not necessarily scared off by the full picture, at least when the context is not a context of a major food safety crisis. At least if the context is not like the context that we have seen, I can say 20 years ago or more with BSE. In many cases, we see differences in consumer reactions when the context is a context of real safety risks, like the first case where we had that ratio of 5:1 that I have shown, versus a more technological risk or a risk or a perceived uncertainty that is resulting from unfamiliarity, like the 2:1 ratio that I showed in the case of cultured meat, which is still a hypothetical product for the majority of consumers. I also showed that there is a diversity of possible response strategies, both personal and expected response strategies from policymakers when facing uncertainty or risk. And yeah, consumers have a very high and diverse expectation as concerns policy responses, information sharing, faster and more communication. These were things that emerged from those studies. And finally, I also indicated the potential of social media, very briefly, as a complementary tool or complementary media to traditional media for specific consumer groups. For example, eventually, in specific contexts or cases, social media can be very helpful to reach specific target groups. For example, some target group consisting of vulnerable population groups in the context of specific food choices. So that's it for my presentation. I thank you for your attention. Thanks again for having stayed with us until the very last moment, and questions are also welcome.
Thank you very much, Wim. I think I didn't stop you, well, even though you went a little bit over time, because I think it's an area where we all need to learn much more. And I think it was very an amazing presentation with a lot of information and very amazing studies that you have conducted. So we would allow for maybe 2 questions. One question is about your thoughts on the potential of communications to address consumer needs in the 3 scenarios. Communication with symptom risk assessment versus communicating over risk analysis, a kind of balancing. And thirdly, communicating risk-benefit assessment. A very complex question, but that's Doma.
That's the $1 million question,
Yeah.
I guess. Yeah, I will not be able to respond on the spot, unfortunately. Yeah. But that's a very interesting thought, because indeed those different scenarios are certainly calling for different approaches. Yeah.
I think
so a one-size-fits-all approach will not be the solution here. And something that I did not mention very specifically, but in those studies, in those consumer studies, and also in communication, it's also tricky to talk about the consumer because, and it's also tricky to average, because the consumer does not exist. There are segments, there are different types of consumers, and also with respect to those different scenarios, they may react quite differently. So a very interesting question. I will take it on board, but I need a bit more time to think about a good response here.
Yeah, and we will certainly, develop it as we go along with the meeting, with the colloquium, hopefully, and beyond. Maybe I'll take just one more question, and then the rest. They are very interesting questions, but we'll have to postpone them for later. What is the role of income and education in consumers' perception?
Yeah, it certainly plays a role. So when I speak about segments or groups of consumers, what we typically do in consumer studies is also we profile them based on this type of socio-demographic characteristics. And there indeed, you see differences with respect to information needs, communication, channel usage, and so on that relate to income and education. So again, this one-size-fits-all approach is quite risky.
Okay, well, I see there is a question that keeps coming, and I'll take it, although we may be pressed for time, because it's important from the point of view of communication. It's a question about whether the consumers have learned to deal better with risk-benefit information after COVID. Having been given, misleading and clear information on both sides, what do you think?
I have no empirical evidence yet on that. But I believe, not specifically because of COVID, but in the last 2 decades, consumers have indeed learned to deal better than before with balancing risk and benefit. In some of those earlier studies, we saw that the risk factor dominated the effect more than we see nowadays. That can also have to do with a kind of je m'en fous, where consumers say, well, in the end, there is positive and there is negative news. There is information that tells us that eating bananas is healthy, but then there will also be studies that say the opposite. So, yeah, it can also be, to some extent, ignorance, which was one of those response strategies, where people in the end say, well, I eat what I like to eat without worrying too much about the healthiness of what I choose. So there are many different factors that may play a role, as I showed in my multitude of factors shaping decisions.
Yeah, I think that is the essence of your work. That it's really not a one size fits all, as you said earlier. But thank you very much, Wim. It was really very, very interesting, and I think you can see the reactions here. People are very much interested in your area of work and in your work in particular. So thank you very much for being with us, and we look forward to the communications during the next 2 days with you. With that, I would like to move. Thank you. I would like to move to the very last point in our agenda, which is a very short presentation by the team leader of the Methodology and Scientific Support Unit of EFSA, Jean Lim. Jean has been actually in the field for quite some time and is a very seasoned scientist who started his career at IBM in '86. That's where we met the first time, and he worked for the European Commission Scientific Committee on Food from 2000 to 2002. So he accompanied the transition to the establishment of EFSA, and since 2003 he's working with EFSA, initially as head of the Scientific Committee unit and then in various other functions. So Jean will introduce to us the breakout sessions, what is expected, what are you expected to do, and how they will function. Over to you, Jean.
Thank you so much, Maggot. I'm going to share. Hope that you can see my presentation soon. Okay.
Yes.
Can you see it?
Yes.
Yes. Yes.
Okay, perfect.
Je moet eerst je iPhone ontgrendelen.
Okay. I got a message from my iPhone. Okay, so you can see my slide now, I hope.
It's not in presentation mode, but I think it's...
Okay. Sorry for that. So it's a little bit late in the afternoon. Maybe that's my problem. Okay, just a short introduction to the breakout sessions that we will have tomorrow and the day after. So what is going to happen? Yes, I hope that you can see the next one. Oh, yes. So we will have tomorrow, we start with breakout session 1. And what is important is that we have, let's say, 3 breakout sessions tomorrow and on Thursday morning. And that will each, let's say, focus on particular topics that we have defined. And I think Maggot was already explaining it this morning, or this earlier this afternoon. The first one is on needs, the second one is on methods, and the third one on Thursday morning will be on data. And what is important is that we have divided the whole group into 4 groups, 4 breakout groups, A, B, C, and D. And each of them, they will have, let's say, in parallel, the breakout sessions as indicated on this slide. So that means that you will have groups of 25, 26 people who will, let's say, have a mixed composition of different affiliations, different expertise that we have combined in each of these breakout groups. So breakout session 1 starting tomorrow on needs. There will be a discussion. After that, it will be about 2 hours. We will have a break in which particularly the chair and the breakout session rapporteur will meet in order to define how to give the plenary reporting of each group. Important to note here is that we would like to have in the plenary reporting all the breakout groups presenting, let's say, the outcomes of their discussions, after which we will then have a discussion that will be chaired by Maggot, and we have then also, again, the 2 overall rapporteurs, Luisa Ramos and Maria Bastaki, to take notes of, let's say, the discussions and the outcome of that. This will be a sequence that will be repeated afterwards, breakout session 2, and of course also then on Thursday morning. So this is the breakout sessions. We have 4 groups, A, B, C, and D, and each having a chair and a rapporteur. There will be, we have also served that there will be more colleagues, let's say, joining each of these breakout sessions in each of the groups in order to help, let's say, facilitating the discussions. So you have probably seen that, let's say, I will first go to, well, this is the guidance that we would like to give for each of these breakout sessions. We have given the chairs and the rapporteurs each a briefing note with the focus and questions. Of course, it's about the topic that we have defined, needs, methods, and data. But underneath there will be, let's say, some sub-questions that we have been providing to the rapporteurs and to the chairs in order to trigger the discussions. So they will be, let's say, helping you to go through each of the breakout sessions, and hopefully we have a good, let's say, exchange of views between all of you in those breakout sessions. After that, we have then the report back to plenary. We have then, after all the breakout groups have reported, we will have then questions and answers after the reports from these rapporteurs. And this is, of course, it's to open the scientific debate on what has been discussed. We hope that we will have input from all the participants in each of these breakout sessions. Around 25 participants in each group. And what I already said is that we have tried to compose the groups in order to have a mixed composition based on the expertise and affiliation. Then, well, some guidance further about, it is not really to agree on details of the strategy. Certainly what we would like to see is that the outcome of the breakout sessions will help particularly the scientific committee working group, which has been established in order to have some directions that we can take. And this is, of course, related to the methodology, the approach that we can, let's say, apply for risk-benefit assessments, but also, let's say, to take into consideration needs that you have expressed during the discussions, and certainly also taking on board if there are particular developments in the approaches that have been used in more recent risk-benefit assessments. And of course, also what we have just been presenting by Wim Verbeke, also particular aspects from a communication point of view, we would like to have addressed in these discussions so that we have some directions to take in the activity which will come later. So a multidisciplinary scientific debate, and certainly also making use of the possibility to identify and acknowledge existing gaps. Then we have done, after the presentation by each breakout group, we are going to and that is the usual outcome of a scientific colloquium of EFSA. We will have a summary report, which is mostly published in a booklet format, and that is planned to happen in the autumn of 2022. Of course, you will be involved in providing comments on drafts that will be circulated before the finalization. And what is also probably very helpful is, of course, the scientific committee will let's say, address the issue of updating the guidance. And we are planning in the summer of 2023 to organize an international workshop where, and that will happen when the draft guidance, the updated guidance, will then be published for public consultation. And in that period that the public consultation will run, we would like to have an international workshop organized so that we can have a discussion about well, the outcome of the discussions that the scientific committee has had in its working group and in the scientific committee plenary. So that is going to happen in the summer of 2023, and you will be informed about, let's say, the arrangements of this workshop. So that was all. I think I would like to wish you all a frank, open, constructive discussion. I hope that I'm sure that the chairs and the rapporteurs, they have been briefed, and we will still take on board also those outcomes from today's presentations that we have received this afternoon. Thank you so much. I'm giving back to Margaret.
Thank you very much, Jean. And colleagues, do not expect that you will be sitting around the coffee table and having a person-to-person discussion. Unfortunately, we will still have it around or sitting by our computers. But nonetheless, we hope that we will have a very constructive discussion over the next 1.5 days. Let me, before we end, just thank all of the presenters. I think we had a very interesting afternoon with a variety of interesting presentation from various areas. And I think it's a very good start for hopefully a very interesting discussion and a very successful and productive meeting. With that, let me wish you all a great evening, and we'll see you all in the morning. Thank you very much, and goodbye.